Hey everyone, welcome to my channel. This is the Computer Vision with Jetson Nano course using Python. Here we are going to learn the basics of computer vision along with their implementation on the Jetson Nano. We will start with the installation and the setup, and then we will move on to the fundamentals of computer vision. From there, we will learn the concept of modules and how we can create efficient modular code that will be used in different projects. Then we will create 3 different projects to apply what we have learned in real-life applications. The first project is the eye tracking, where we will teach the Nano to track a human face. Then we will have a robot car, which we will build and program to track objects and follow lanes like a self-driving car. The last project will be face attendance, where we will learn to recognize faces and store them in real-time database. If you are a beginner, don't worry, this course is for you. We will focus on the implementation part so that you can get the most practical experience out of this. Even though this is a premium course, I have decided to launch a part of this course for free so that everyone can benefit from it. If you would like to view the complete course, you can check it out in the link in the description below. So let's get started. For the installation process, we will head on to the Nvidia's website. Here we will click on Get Started. Now they have given a very good explanation of each step. So we will start with the introduction. Here we have the Jetson Nano kit, and we can see that all the different parts they have explained here, and then what is included in the box and the items that you will be needing. Now, the most important thing you will need is the micro SD card. So they recommend using a 32 GB card, and you will also need a USB keyboard and mouse, and of course a computer display. Now later on we will also learn how we can use it without the display as well. Then we have the micro USB power supply. Now this has to be 5 volts and 3 amperes. You can get away with 2 amperes as well, but it is recommended that you use up to 3 amperes. So here are some of the details of the power supply. So you can go through these, and we can move on to the next step, which is basically writing the image to the micro SD card. Now here the important thing is to download the Jetson Nano Developer Kit SD card image. Once we download this, we are going to burn it to our SD card. So we have the instructions for Windows. So we will first do the formatting of the SD card, and later on we are going to use Etcher to actually burn it to our SD card. So first of all, you have to download the SD card formatter. We will go there. And over here we will go down and we will agree and we will accept. So this will start the download. I have already downloaded and installed. And the same thing we will do with the Etcher. We will go to the Etcher website, and here we are going to download this. Once you have done that, we are going to open the SD card formatter. So here you can see that I've already inserted my SD card. So this is 32 GB. So we are going to do the format of this. So let's get started. Once the format is complete, we will close this and we will go to the Etcher program. Once it opens up, we are going to flash from file, and we will go to the folder where we have downloaded the image. So here we will click on the image and we will open. We will select the target. So our target is our 32 GB card, and we will select that, and then we will start the flashing process. So as you can see, it says here it will take about 12 minutes. So we will wait for it to finish and then we will continue. So now that the process is complete, we are going to insert our SD card to the Jetson Nano. So we will first close this and we will remove our SD card. Now we will insert the SD card at the back of the Jetson Nano. So here we have the SD card and the slot is at the back. So we are going to insert it like this. This is spring loaded, so it should go in easily. I have also added these spacers so that it is easier to put on a table. Now the next step would be to add a Wi-Fi dongle. So it does not come with built-in Wi-Fi, so we are going to add that dongle. Then we will also insert the HDMI cable, the power cable, and at the very end we also want to attach a mouse or a keyboard. So I have a dongle here that is basically for both mouse and keyboard, so it comes as a combo, and that is very useful because it uses only one USB port and it connects to both the mouse and the keyboard. So now that is done, so let's go to our Jetson Nano and see how we can set up. Now, because this is the first setup and I'm not using any screen recorder with the Jetson Nano, that's why I have this camera fixed in front of the screen. So it is a little bit blurry, but stay with me. And once we are done with the installation, I will install the screen recorder and we will have this nice crispy image. So here we have the system configuration. So we are going to review and accept the license and we will continue. Here we will select English. We will continue with English. Here you can select your Wi-Fi. So I'm going to select my home Wi-Fi. Now we will continue. We'll go to next, and here we will type in the name. So I will type in my name. And the password, I'm just going to keep one for now, which is the shortest and the easiest password ever. We will continue with the default value. So now the system is rebooting and hopefully we will have our operating system ready. And there you go. So now we can just log in with our extremely weak password. And there you go. So now here we have the keyboard shortcut. We are not interested in that. And here we have some guide. We are going to skip that. And there we have it. So now we have our system running. So now that we have our operating system running, the first thing we will do is we will update if prompted. So here you can see there's a software update going on. So it asked me whether you want to update the system and I said yes. So that is the first thing you will do, and if it asks you, and then the second thing is I don't like to keep any of these things here, so I will just remove this to the trash, and then these also I do not like to clutter up on the main page. So then we have our store. Here you can find all the softwares and you can search for them and you can search for updates. Over here but we are going to use the terminal to actually install any of our packages. So we will go and search for that. So we will write here terminal and we will open that up. Now, what I like to do is to save it here. So we will lock it to the launcher. So this way, even if I close it, I still have the option to open it from here. Now, to run our code, we are going to download an IDE. IDE stands for Integrated Development Environment, which means that it is similar to a notepad where you can type in your code, but it will have more functionality such as debugging or letting you write efficient code and things like that, which allows us to write more quickly and more efficiently. So we are going to go to our Chromium and we are going to find the VS Code. Now, previously, there wasn't an official release from Microsoft for the VS Code, which is compatible with the Jetson Nano, but now they have finally released it, so we can go ahead and download that. So you will go to other platforms, and here you are going to download the ARM64. Once the download is complete, we will go to our downloads folder and we will open up the file. Now we can hit install. Now we will search in our computer for the VS Code. And there you go. So we will click on that, and again we are going to lock it to our launcher. And we can close this folder as well. Now here we have to drag in a folder, or we need to create a new folder. So we will create it on the desktop, and here we are going to write code. We will double click it and we have the empty folder, and now we can simply drag it in to our VS Code. So here we are going to create a new file and we will call it chapter1.py. Now, as you know, Python is already installed in the Jetson Nano image, and we also have the OpenCV installed, which is the computer vision library that we will be using. So to make sure that computer vision library CV2 is present, we are going to check it here. We are going to write import CV2, and then we will write print, and we will write CV2 dot version, like this. So we will save this. Now, to run any file, we are going to open it in terminal, and we can use the integrated terminal within our VS Code. So what we can do is we can right click here and we can say open in integrated terminal. And here this folder is opened up now, which is in the desktop and code. And here we can write Python 3, and then we can write chapter1.py. So here we have the answer. So we have the version 4.1.1 installed as our OpenCV. Now, throughout the course, we will be needing a lot of different resources. So I have compiled a resources folder and we will just drag it in. This folder will be available. We will add it, or do we want to copy? We want to copy the folder. So here inside we will have, there you go. So here inside we will have the resources folder copied. So we could remove this one to trash. So this folder will be available on the course page itself. So you can download it from there. So the first thing we will do is to import an image. So we are going to write here img is equals to cv2.imread. So this will read in our image, and our image is basically available in the resources folder. So if we open this up, we are going to import the test.png. So this is the file that we want to import. So we will close this and we will write here that in the resources folder we have test.png. So this is the file that we want to open, and then once it opens up we want to display it. So we will write here cv2.imshow, and we are going to write here the window name, let's say output, and then we will write the image that we want to display. And we also have to add a delay so that it does not close once it opens up. So we will write here cv2.wait key, and here we have to make sure that the K is capital, and then we will write 0. 0 stands for infinity in this case. So if you write like 1, that will be 1 millisecond. If you write 1000, that will be 1 second. So here, once that is done, we are going to go down here and we will run this again. But before you run it, you will see that there is a dot over here. This dot means that the file has not been saved. So we will save it and then we will run it. So there we go. So we have our image. It says output, and you can see it has been imported properly. So we can close this, and this is basically our image part. So we can write here importing an image. Then the next step would be to import a video. So we are going to write here import video. Now with video, it's a little bit different because we are not just getting one single image, we are getting multiple images each second. So we have a total of 24, maybe 30, maybe 50 frames per second, who knows. So what we will do is we will create a while loop, and with this while loop, every time we are going to grab an image, we are going to grab the frame from that video, and then we are going to display it. So to do that, we are going to write here, let's write here, or should we comment this out? Yeah, let's just remove this, and we will remove it from here and we'll put it here. So all of this is one code, and then we are writing the second code. So instead of writing it in a different file, I'm writing it in the same file. So here we will write import cv2, and before we go any further, we are going to comment this out. So then we are going to write frame width is equals to 640, and the frame height is equals to 480. So these are the parameters that we will use to resize our image or the video. Then we are going to use the video capture function to actually create our video capture. So we will write here cap is equals to cv2.video capture, and inside that we are going to reference our video. So here we will say resources, and then we will say test underscore video dot mp4. So as you can see here, this is the video that we want to run. So that should be good enough. And then we are going to create our while loop. So while true, we are going to get in whether it was successful or not, and then we will get our image. So these are the values that we will get in return. So, and then we will ask our capture device to read the frame. So this is the capture object reading the frame, and then we will resize this image. Now we are resizing it so that it is easier to see. So we are going to write resize image, and we are going to give in our frame width and the frame height. So this way it will resize, and then again we can say that cv2.im show, and we have our result or output, whatever you want to call it, and then we have the image that we want to display. Now, at the end of the day, we have to add a delay, but what we will add, another feature, is that whenever we press the Q button, the frames, they stop, or the program itself comes to a halt. This is important because sometimes you are using a webcam and you want to stop it, because it will not stop automatically. Even if you close the window, it will pop up again. So what you have to do is you have to break the process, which is basically the while loop. So you will put a condition to add the break. So here we will write if cv2 dot wait key is 1, and we are going to write 0xff. So don't worry about this part. It just means that you are waiting for the Q button. If it is pressed, then you are going to break from the while loop. So that is pretty much it. And what we can do is we can run this part. We will first save it, because you can see here we still have that dot. So we will save it. We will go back here and we will run it. By the way, if you're not familiar, I'm pressing the up button, the arrow up button on the keyboard to actually display this, the commands from our previous run. So it is saying that the image resize. Okay, I forgot to write cv2, cv2.resize. So we will save that and we will run it. And there you go. So this is our video being played, and I believe it's been played with more than 30 frames per second, because the video itself is 30 frames per second, but you can see that is a bit fast. And then we get an error because all of the frames have been done. So they have been displayed and there are no more frames to display. So in this case, you can loop it again. You can check when the frame count is reached at the max. You can go back to the initial frame count, but we're not going to go into that much detail. We will go into the webcam next. So we can basically comment all of this out, and then we can write here run webcam. So here we are going to again import cv2, and then we are going to pretty much copy all of this because it is very similar. So we can copy that instead, and we can uncomment it. So comment uncomment is from control and backslash. So if you press one time, it will comment. If you press again, it will uncomment. So that is the main idea. Now with the webcam, the very simple idea is that you simply replace that video capture ID with your camera ID. So if I write 0 here, that will actually get the webcam from our device. Now if I write the link or the path of a video, it will get that video. So this is how simple it is. So let me connect my webcam and then we can play this. And there you go. So this is coming live from my webcam. So it is a little bit shaky. I'm not sure why. Maybe because I'm recording the screen as well. Normally it's not that shaky. It is very clear. It is very fast. So most likely because I'm recording as well. Okay. So we can press the Q button and it will stop. In this chapter, we are going to learn the fundamentals of image processing. So we will learn a few functions that are very important when you are using different kinds of image processing techniques. So first of all, we will create a new file. So we will call it chapter 2, and we will say this is a py file. And then we are going to import cv2, and we will also import numpy as np. Now, to make sure that numpy is already installed, we are going to run this. So we will open in integrated terminal, and here we are going to write python 3 chapter 2.py. So the spelling for Python is wrong. And there you go. So that confirms that NumPy is actually installed. So we do not need to worry about that. Then we are going to import our image that we want to test. So the same way that we did earlier, we are going to write img is equals to cv2.imread. And we want to read from the resources, and we want to get the test image, test.png. Then we are going to display this. So we will write cv2.imshow, and then we will write the window name, let's say output, and then we are going to write that we want to print this image, or we want to show this image. So, and then we will write cv2.wait key so that it does not close until we tell it to. So that should run fine as it is. So let's run it. And there we have it. So we have our image as earlier. And now we are going to convert this image. We are going to apply some techniques to convert it and then display. So the very first thing we will do, we will convert it into grayscale. So we can write img gray is equals to cv2.cvt color. And then inside that, we will write that we want to input this image and what type of conversion we want. We want cv2 dot color. All of this should be capital letters. Color underscore bgr to gray. So that is our conversion. And now we want to display this. So we will copy this code and paste it. And here we can write image gray, and here instead we can write image. So let's write gray here as well. So we are displaying the image gray with the window name image gray. So this is what this is doing, and now we can save it first and then we can run it. And there you go. So this is the image gray and this is the actual image. So let's close that by hitting any button. And then we are going to blur this image. So we will write image blur is equals to, there are many methods of using blur. We are going to use the Gaussian method. So we will write cv2.Gaussian blur. And we are going to write inside that we want to blur the image gray. So you could blur the image as well, the colored one. But we are deciding to blur a gray image. Now here we have to give the size of the kernel. So there is a kernel that actually, a kernel is just like, you can say it's a matrix. So the matrix will move around the image and it will multiply the values so that there is blurriness added to it. So we need to define the size of that kernel. If the value is high, then that means we will have more blur. If the value is low, we will have less blur. So here we can write, for example, 7 by 7. And these numbers, they have to be odd. It can be 3 by 3, 5 by 5, 9 by 9, and so on. And then we have the X and the Y value. So you can write a value here as well that will increase the blurriness as well. So if you keep it at 0, it will be fine. But if you add, for example, 5, it will increase the blurriness. So you can play around with these parameters. And you can read about these parameters as well in the actual documentation. So let's copy this part and we will paste it here, and we will write here that this is the blur image, and we will write here image blur. So let's save this, and now we can run this. There you go. So now you can see there's quite a significant amount of blur. Now if I go back and if I change this value to 0 and if I change this to 3 and 3, now let's see what happens. Now you can see the blurriness is very subtle, and it's not very clear that whether a blur is added or not. You have to really look or find it to understand where the blurriness is. Anyways, so this is the basic idea. So you can increase and decrease. So then we can find edges. To find the edges or the corners, we can use the canny edge detector. So here we can write image canny, and then we can write cv2.canny, and inside canny we have to give in the image. So let's say we are giving in image blur, and then we are going to define the two parameters. So let's say the first parameter is 150 and the second one is 200. So these are the two threshold values that you can play around with. So in the future videos, we will also check how we can play around with these values using a trackbar, so that it is easier to find the correct value for your application. So we can save this and we can go down and we can run it. But we did not actually show, so we need to show it first. So here we are going to write image canny. Why is there an A here? It should be without an A. Okay. And here we can write canny. So let's run this. And there you go. So now you can see there is this image with the edges. Now if I reduce the values here, for example, let's say I put it as 100 and 150, then the edges will appear more. So if I go back, what is happening here? It didn't quit. Yeah, it didn't quit yet, so we need to close this. There we go. And okay, I pressed it multiple times. Okay, now we can run it, and there you go. So now we have more edges than before. So decreasing this value will have more edges, increasing it will have less. So this is basically the canny edge detector. So then we have two more functions. One is the dilation and the other one is erosion. In dilation, what happens is that we want to increase the thickness of our edges that have been detected. And erosion is the opposite of that, where we are decreasing the thickness of those edges. So let's see how we can do that. So we will write here image dilation, and then we can write cv2 dot dilate, and we will write we want to apply it on image canny, and we will define a kernel. This time around we have to define the actual kernel, not just the size. So we will define that, and we have to write the iteration. So iteration is equals to 1. So if you have more iterations, it will have more effect. It will increase the thickness more. So we will see how it affects. But before that, we need to add a kernel. The kernel we will create by the NumPy library. That's why we imported this. So here we are going to write kernel is equals to numpy.ones. So it is a kernel of ones, and we want to give it a size 5 by 5. So again, this is just a matrix, and we have the size of 5 by 5. And another thing that we want to define is what type of values are inside of it. So the values that are inside are basically numpy.unsigned integers of 8-bit. Unsigned of integers of 8-bit means, so 8-bit means 2 to the power of 8, which is equals to 256 values. And if we go from 0 to 255, that will give us 256 values. Then unsigned means it is from 0 to 255. If it was signed, it will be minus 127 to 127. So that will be if it is signed. So that is your main idea. An integer is of course a whole number. It's not decimal places. So hopefully you already knew that. So now that our kernel is declared, we can run this. So let's copy this part here, and we can write here image dilation. And yeah, we need to change this to dilation, and that should be good. So let's run this. So there's a problem. Iteration is an invalid argument, probably the spelling. So iteration, spelling seems fine. I think it might be S, iterations. So let's try that. Yep. So it is basically iterations, not iteration. So here you can see that this is the edges. These are the edges. And now you can see that they have been thickened. So we can see now we have thick edges. So the same way we can do the inverse of it, where we will have less thickness than before. So to do that, we will go back and we will copy the statements and we will use the erosion function. So here we will say erode, and here we will say erode as well. So this will give us the erosion function, and we will apply it to the image dilation instead. So that is the idea. So let's copy this and we will paste it down here. We will write erode and image erode. There we go. So let's run this and see what happens. And there you go. So erosion, now you can see it is the thickness is less than the dilation, and the dilation thickness is more than the image canny. So this is how the cycle works. And as I mentioned before, if you want to increase the thickness even more, you can increase the iterations. So let's put something drastic. Let's say 5. That will be a very huge amount. Let's see how that affects. There you go. So now you can't even tell what is happening. So yeah, as I mentioned, 5 is a huge value. So we could try, let's say 3. Still, it's quite heavy number. Anyway, so I hope you get the idea of how you can apply these functions. So these are the 5 main functions that everyone should know if you are learning image processing or OpenCV. So later on, we are going to use each one of these in many different projects, so it will make it easier for us to play around with different images. If you like the video so far, give it a thumbs up and don't forget to subscribe. In this chapter, we are going to learn how to resize and crop images. So let's go ahead and create a new file, and we will call this chapter3.py. So first we will import CV2, and then we are going to import numpy as np. So again, we are going to read our image first. So we will write img is equal to cv2.imread, and then we will write that we want to read from the resources, and inside the resources we want to read test.png. Then we can do one thing. We want to know what exactly is the shape of our image. What is the size of this image, so that we can know how much can we crop, how much can we resize, things like that. So to do that, we have this functionality where we can say image.shape. .shape will give us the size of it. So we can write print image.shape, and that will give us the shape of the image. So let's save it And here we will say Python 3, and we will say chapter 3.py. And there you go. So the size of our image is 559. This is the height. Then we have 768. This is the width. And then we have 3. 3 means it is 3 channels, red, green, and blue. But in OpenCV, we use BGR, which is blue, green, and red, instead of RGB, which is red, green, and blue. So first we can resize the image. We can write img resize for our resize image, and then we can write is equals to cv2.resize. So this is the function that we will be using, and then we can write in which image we want to resize, and we can give in the size of that image. So there are two methods that you can use resize. One is by giving exact values. So for example, we want to resize it to 640 by 480. And the other way is that we want to keep the aspect ratio same, but we want to scale it down, for example, 50%, 20%, or we want to scale it up to 150%, something like that. So the first option is by pixels. So here we can write, for example, 640 by 480. So this should give us the size, and we can write here cv2.imshow, and we will write here that we want to display our image, and we want to display img as before, and then we will write cv2.imshow, and then we want to display our image, resize option number 1, and we can write here image resize. Right, so that should be good enough, and we need to write cv2.wait key, and then we will write 0. We will save it, and we will run it again, and there we have it. So this is the original image, and this is the image resized. So as you can see, the aspect ratio is probably not the same. It will be a little bit different. We could really squeeze it out as well. For example, if we write here, let's say 500, and we write here like 200. So it is quite dramatic, but let's see the effect. So here you can see it is quite squished now, and this is how you can change by exact pixels. Now the second option is to change by what do you call the scale. So let's write this as resize 1 and resize 2, and we can write here resize 1, and we can copy this and write here resize 2, and here as well we can write resize 2, and instead of giving in a value, we will put 0 and 0. So we don't want to change it by this, and then we can write none for the output, and then we will write the scale value. So scale in X, let's say 0.5, and scale in Y, let's say 0.5. So this will give us 50% of our image. So let's run it. And there you go. So now you can see that we have the exact same aspect ratio, but it is scaled down to 50% of the original size. So most of the times it is better to use this method, which is basically the scaled down version, so that you don't lose the aspect ratio of the image. So if you want to check again, you can print the same thing. You can copy this and paste it here, and you can check by changing this to image resize 2. So it will first print the size of the first image, and then this is the size of the second image. So if you divide this by 2, you will get this. If you divide this by 2, you will get this. So that's how you know. So that's how you can basically resize an image. Now, the second thing we will learn is how to crop an image. So the cropping is actually very simple. And the reason is that image is basically a matrix. So what we can do is we can define where to begin the matrix and where to end the matrix. So we can use that functionality that image is a matrix to our benefit, and we can simply give in the values and it will do the cropping for us. So we can write here that our image crop is equals to, we write here image, and in the brackets we are going to define our values. So y will come first and then we will have x. So in y direction, let's say I want to put 100, and then in x, let's say again in y, the final value I want to keep as, let's say, 200. And then in the x direction I can say, for example, 200 and 300. So let's see how that performs. So let me copy this part and we will write here image crop and image crop. Oh, it's cropped. Let's write it crop. So let's run it. I think the previous one is still running, so we need to close it. And now we can run it again, and there you go. So here you can see we have the crop. So we are getting the crop right about here. Yep, so that is the crop. Let's try to figure out the value around my face. So if we think about the size itself, then you can see that we have the y as 100 to 200, and then we have 200 to 300 in the x direction. So for y, it is from 100 to 200 to 300 to 400. So if I want to capture my face, I will go around 400. So the starting point is 100. We can go a little bit back. We can say, for example, 50 to 450. 450, not 150. And if we run this, we need to close that first. So if we run this now, the y should be better. There you go. So the y is now better. It's almost, yeah, I think it went too far, maybe a little bit less. So let's say 375. So again, we need to close it and we can run it again. And yeah, I think this time it's much better. So this is good. And now we need to do for the x. So the initial value is a little bit less. So we can go a little bit further. So right now it's 200. We can say maybe 220. And then from 220, we will go maybe 100, 200, maybe 300. So it will be 520. So let's try that out. And there we have it. So now you can see that I have cropped my face region from the image using the crop functionality. Maybe a little bit down as well. But anyways, I hope you get the point. So this is how easily you can crop an image. So let's say we found the face. So we will have the bounding box. Let's say using a different technique, we are finding the face. We found the bounding box. Now using those points of the bounding box, we can crop our image and we can make it a separate image. So this is very useful in many different projects. In this chapter, we are going to learn how to draw text and shapes on images. Now, this can be very useful whenever you are detecting objects, whenever you're tracking something. So whatever you found, you can actually write on top of it. What did you find? For example, if you're detecting colors, you can say, okay, this is blue color, or you can even show the circle drawn in blue color and things like that. So in this chapter, we are going to learn all of this. So we will create a new file. We will call it chapter4.py. And in chapter number 4, we are going to first import CV2. And then we are going to import numpy as np. Then we are going to create a blank image. So we are not going to use an image from our resources, we are going to create our own. So we will write here image is equals to numpy.zeros. So as I've mentioned before, image is just a matrix of values. So numpy library actually helps us create this matrix. So that's why we are writing numpy zeros. And then we want to define the size of this matrix. So we will say 512 by 512 and by 3. So it has to be 3 channels, so 3 colors. And then we need to define the value, the type of value. So we will write here numpy dot unsigned integer of 8-bit values. So again, from 0 to 255. So that is the main idea. And then what we can do is we can color this image. So right now it's zeros, so it is all black. If we want to change the color, we can write img, and then inside we can write colon. So it means apply to all. And then we can write the color value. So let's say we want to make it blue. So we will say BGR. So B should be 255 and G should be 0 and R should be 0. So that should give us a blue color. So let's print that out. We will write cv2.imshow, and then we will write the window name, let's say image, and then we will write the actual image we want to display, and then cv2.wait key, and we will put a 0 in between. Then we'll go to the terminal and we will write Python 3 and we will write chapter4.py. And there you go. So now we have a blue image. So if I wanted to change, I will change this, let's say to green, or let's make it purple. So we can write 255 here and 255 here. So that will give us a purple value. We need to close this one first. We will close this by pressing any key and we will save it. We will go back to the terminal and run it. And there you go. So now you have a purple image. So this way you can create any color that you want. For this example, we are going to put a white color so that we can draw easily everything on it. Okay, so the next step would be to draw a circle. So it's very simple. Whatever shape you want to draw, it basically uses its name. So we can write cv2.circle, and inside that circle we have to define what is the image that we want to draw on, and then we have to define the points, the center points where the circle starts. So we will write here exactly in the middle. So half of 512 is 256 and 256. So it will be right in the middle. And then we have to give it a radius. So let's say our radius is 150. It's quite a big circle. And then we will put an orange color. So that orange color I have already checked. It's 0, 69 and 255. And then we have the option to fill it or give the thickness. So let's say we give the thickness of 5. Let's see what happens. So we will close our previous running and we will run it again. And there you go. So we have an orange circle, but you can see it's only an outline, means it is a threshold. So what we can do is we can simply change this to, let's say 15, and it will increase the thickness of it. So let's close this and run it again. And here you can see the thickness is increased. Now, if I want to make it completely filled, I will write here cv2.filled, and this has to be all capital letters. None of them should be small letters. So we will write it here and then we can run it again. And there you go. Now we have a big round circle filled completely with our orange color. So that sounds good to me. That seems good to me. So next we are going to draw a rectangle. So here we will write cv2.rectangle. So we will give in our image. And then the second parameter is the points, the left corner point. So you can call it the origin. So let's say that is 130, and then we have 296 or 226. All these values I have checked before, that's why I'm giving exact values. but you can feel free to play around with those. And the second parameter is our bottom right value. So this is the diagonal value. So we will write here 382 and 286. And then we are going to write, no, the comma should be outside. So then we are going to write the color value. So let's say it is white, 255, 255 and 255. And then we also have the option to fill it or change the thickness. So let's say if we put the thickness of 5 and if we run it, there you go. So this is the thickness of 5. But in this case, again, we want it filled. So we will write cv2 dot filled all in capital letters. So let's run that. There you go. So now we have you can say it's like a stop sign, but that is not what we are going for. Believe me. Anyways, so next we are going to create a line. So cv2 dot line, and then we will write our image, and then we have to write the points. So like we wrote the points here, the same thing we will do. We will write 2 points. The first one will be the starting point and the second one will be the ending point. So here we are going to write those. So this will be 382 and 296. And again, we will choose the color of white because it is on the orange. So it will be quite clear. And this time around, we will not, we don't have the option to fill. We have the option of the thickness. So here we will put the value of 2. So let's save it. And now we can run it. And there we go. So now you can see there's a nice line at the bottom and it looks quite elegant. Let's close that. And the last thing we will do is we will put some text on it. So we will write here cv2 dot put text and not test. So we will write here img. So we want to put our text on the image, and then we will write what we want to put. So I will write Murtaza's workshop because that is the name of my channel. And then we will write here 137 and 262. And then we will write cv2 dot. Now this is a little bit different because we have to define a font. So OpenCV has a few fonts you can check in their documentation. And I can add some fonts here in the comments as well. So the very common one of the very common ones is font Hershey Duplex. So we will write here Hershey Duplex, Hershey Duplex. And then we will give it the scale. So let's say the scale is 0.75. And then we will give it the color. So we want orange color because it will be inside the white. 69 and 255. And at the end of the day, we have to define the thickness of this as well. So scale is different than thickness. I will show you what that does. So let's say I put 1 here. So let's run this. So there you go. So now you can see Murtaza's workshop written here. Now let's increase the thickness of this. So let's make it 3. There you go. Now the letters are really thick and it's a little bit hard to read. So we will go back to, let's say 2. And now we will change the scale. So let's see what the difference is of the scale. So we will write 1.5 and then we will run it. And there you go. So now the scale has changed. And as you can see, the text is going outside the image. So that is not good. And we will retrieve back to 0.75. So let's run it again. And there you go. So now we have a nice clean image with a circle drawn, a rectangle drawn, a line, and some text, as you can see. So this is a very easy way and a very useful thing to learn where you can, whenever you detect an object or track something, you can put some text, you can draw some shapes on it. Let's have a look at the concept of modularity. Now, we will be using modularity throughout this course. So let's try to understand it by the example of a simple car. So let's say that we want to build a car. So we will have a lot of different components that we need to put together. For example, we will have an engine. We will also have some seats. Then we have some wheels, and we also have, let's say, an entertainment system. So all these things, they will not be manufactured or produced in a single factory. They will have different factories that will produce them, and then they will be assembled together. This way, if there is a problem, for example, in the entertainment system, you can go to that factory or you can contact their service to get your problem fixed. And if there is a problem with this entertainment system, you can replace only this part rather than changing everything else in the car. So the same goes for the seats, the same goes for the wheel. The wheels and the engines are not made in the same factory. They are produced separately and they are sold separately sometimes as well. So you can change only the wheels. You don't just change your car, or you don't change the engine when you have to change the wheels. So this is how powerful modularity is. It allows you to separate or divide your project into separate pieces so that it is more manageable in the long run. When it comes to coding, let's try to understand how modularity works there. Let's say that we have a smart car that will detect an object, a colored object. In this case, it will be red, and wherever that is, it will rotate based on that color. So what will happen is that whenever we want to detect the object, we will have a module for that. So there will be a color detection module, and then there will be a module to rotate the wheels. And we will have a main code between them that will ask the color detection code to send me the location of the colored object. And then based on that location, it will send the commands to the motor to rotate based on that location. So this will look something like this, where you have your color module, you have your main code, and then you have your motor module. So whenever you want to detect, you will ask your color module to find the color and give you the X and Y position. And based on that, the main code will send the command to your motor module. So in reality, these modules are just files. So these are scripts of code. So you can see here we have one script here, then we have the main code script, and then we have the motor module script. So the idea is that when you have modules and you put them together, it becomes a package or a library. But we will not go into that. We will just focus on the modules. So let's say we have the color module, and inside that module, you will have different functions. For example, to find the color, then to find the X and Y position, then to change the size. There could be many different functions or variables within this module. So if I want to find the color and move my robot based on that color, I will simply say in my main code, find color, and then I will define which color I want to detect. For example, here I will say red. Then the red color will be detected using this function, let's say, and then it will find the X and Y position of this detected object, and then it will send us back that you need to move left. So what we will do is, in the main code, we will send the command to our motor to move left. And then that will go to the motor module, and it will do all the processing that is required to move the motor left. So we do not have to worry about the teeny tiny details every time we create a new project. So once we create a color module, we can use that color module in any number of projects. And whenever we make some changes to that color module, we will call it a new version. So this way, it will be very easy to maintain your code, and you can use the same thing in many different projects. And as you can see, it is a single line that you have to write, and that will give you all the functionality in that module. Even if it's 100 or 200 or even 1,000 lines, you will be able to get that functionality within a few lines of code within your main script. So that is the power of modularity. So here are some of the modules that we will be learning or we will be creating in this course. We will have the color detection module that will allow us to detect any different type of color. We can assign, for example, we want to detect green, red, blue, whatever it is. It will give us the image of that detected color. Then we will have an object detection module which will find an object and it will give us the bounding box around it and it will send us back that information. So we can do any number of things with that information. Then we have the face recognition. Face recognition is where we find which person is detected. So for example, is it Bill Gates? Is it Elon Musk? Is it Jack Ma? Whoever it is that is being detected. Then we have the RGB LED. So let's say we want to indicate something. So instead of writing all the code for an LED light to turn on and off or to turn on different colors, what we will do is we will just say LED turn on, let's say red. So it will turn on in red color. We will say LED turn on blue. So it will turn on in blue color. Then we have the shape detection. Here we will find the contours or the shape of the object and we will send it to our main script and we will be able to use that to find different objects, their shapes, whether it's a rectangle, a square, and we will be able to differentiate between different shapes. Then we have an Arduino module. This module will help us communicate with the Arduino. So if we want to send commands to, let's say, our motor that are connected to the Arduino, then we do not need to worry about all of the digital rights, analog rights, all of the initializations and anything like that. All we need to do is, for example, we will send the command, let's say 30% of the power. Let's say 50% of the power minus 30%. So it will go in reverse. Then let's say we will say turn 50%. So it will turn with 50% speed. So that is the main idea. And then we have the, by the way, you can use more things on this as well. For example, you can detect the values of, let's say, a distance sensor. Then you can check with potentiometer, humidity, temperature sensor, and you can attach this to any type of peripheral you can attach to an Arduino. Then we will have a real-time database. This module will help us send our information to a real-time database. So you can use this for a website, for example. So whenever we will definitely use this for the face recognition. So whenever a person is detected, we will take their name and we will send it to the real-time database along with the time that they logged in. So that will send it to our website database and it will store it there so that we can view it later or we can make use of it. So this is basically the idea of modules, and you can see how powerful they are and how easily can we create them and use them in different projects. So that's why we will be using the concept of modularity throughout this course. In this chapter, we are going to learn how to detect objects in an image. Now, we will be using a very basic and very common method proposed by Viola and Jones, and we will see how we can use Har Cascade files to actually detect different objects. Now, in our case, we have a trained file for a face, but you could replace it with anything. You could customize with your own training data set, or you can find many different files online as well that you can use. Now, the second thing is that once we learn how to detect the objects, we are going to create a module out of it. So we will write the script in a way that we can use it in different projects later on as well. So it will be easier to maintain and it will be easier for us to read as well once we are done with the code and later on when we start reading it to understand what we did earlier. So let's get started. Now we will create a new folder by the name modules and we will put all the modules in this folder. We will create a new file and we will call this object detection module.py. So first we are going to import CV2 and then we are going to import our image. Now our image is cv2.imread and then we have it in the resources folder, and it is called test.png. And then we will say cv2.imshow, and we will say output, and then image, and then we will say cv2.waitKey and 0. So this is the basic idea. Let's just run it to see everything is working fine. We can write here. Now we do have to go into this folder, the modules folder. So we can right click and we can open in integrated terminal. Then we can write here Python 3, and we will write the name object detection module.py. Okay, probably I wrote the spelling wrong. Detection module. Let me write it again. Python 3, and then we will write object detection module.py, and there you go. So we do have an error. Yeah. So the error is now that it's trying to find the resources folder inside modules. So it's not inside the modules folder, it is outside. So we have to put 2 dots and slash here to go to the previous folder, to the parent folder, and then search over there. So we can write again, and there you go. So now you can see we have our image. Okay, so that's good. And next thing we will do is we will import that file which has the information of detection. So we will call it face cascade, and we will say that is equals to cv2 dot cascade classifier FIER, yes, and then we will write the path of that classifier. So here you can see in the resources folder we have two. We have frontal face default, and we have Russian plate number. So you could find number plates on a car as well. So these two are default on the OpenCV website. You can download it from there, or you can find it on my course page as well. So then you have to write the complete name. So I am quite lazy, so I'm just going to copy it from here, and I will just paste it here. And as earlier, we have to write resources, and before resources we have to write the parent folder as well. So this should allow us to import this. So let's see if it imports. Yep, so we don't get any errors, so that is good. And next thing we will do is we will find the objects in this image. So before we do that, we can convert it into grayscale. Now this is optional, it's up to you if you want to convert. So we can write here image gray is equals to cv2.cvt color, and we are going to write img, which is our image, and we will write that we want to convert it into color underscore bgr to gray. So this way it will convert the image. And what else? Okay, so next we will find our objects. So we will write here objects, or in this case it's faces, but let's just write it objects. Objects is equals to objects, or for now, okay, let's keep it as face, and then we can change it later. So this is our faces, and then we can write here face cascade and dot detect multi-scale. The S and M are capital, and then we are going to write that we want to find it in the image gray, and we have the scale factor and the minimum neighbors. So the scale factor and the minimum neighbors, you can read more about these on the OpenCV website, but changing these parameters will allow you to trade off between speed and accuracy. So here in the scale factor, we can write, for example, 1.1. And then for minimum neighbors, let's put a random value, let's say 4. So again, you can play with these values to find the best results. So we can save this, and next we can find all the faces and then we can draw them. So we will write here for X, Y, W and height, width and height. In faces, we are going to say cv2.rectangle, and then we will say that we want to draw it on our image, and we will give in the X and Y coordinates, and the diagonal coordinates will be X plus width. So we will write here X plus width, and then we will have Y plus height. And then we will write the color. So let's say the color is purple, 255, 0 and 255. And then we can write the thickness. So let's say 2. So this should work. Let's try it out. And there you go. So now you can see there's a purple rectangle around my face that has been detected properly. So if we have another image with multiple faces, it will detect that as well, and it will put those rectangles around each of the faces. So this is how you can find different objects, or in this case, we are finding a face. Now, the thing is that this is a very simple method, and what we can do is we can use this functionality, we can make it modular so that we can call it from other scripts as well. This way, we will be able to use it in many different projects without rewriting the code again and again. So how do you create this in a module? So with the module, we have to make sure that, first of all, it can run by itself. And secondly, it should be accessible by other scripts as well. So here we are going to break it down to different functions, and we will try to make it as modular as possible. So the first thing we will do is that we will check whether we are running this script or we are calling this script from another script. So to do that, we will check, we will say if underscore underscore name underscore underscore is equals to underscore underscore main. So this means that if we are running this script, then we will do something. Then here we will write anything that we want to run if the module runs by itself. So here normally we can write a main function. So this main function will tell you how to actually use this module if you want to call it from another script. So we can write here that this is our main function. And inside that main function, we can write, for example, we can put this part here, which is first of all to get our image. So this will always be different. And then we also have to declare or to get our cascade. Now, in this case, we are saying face cascade. You can say anything. This is just an example. But in terms of function, we have to use objects because it is very generic. We are not just doing it for faces. It can be used with any objects. So this part here can be converted into a function because this is the main functionality that we will be requiring every time we want to detect an object. So we can write here, let's say find object, and in here we are going to place all of this. Now the IM show should not be in find objects because it's not always that we want to display something. Maybe we just want to find the rectangle and we will use their values and not display them. So we have to put it outside. So you can see now we have it outside. And now what we can do is we can call this function. So we can say find object or should we call it objects? Let's say we'll call it objects. That sounds better. So we'll find the objects, and how do we do that? So we have to give in our image, and we have to give in the cascade. So object cascade. So we should not write face cascade. Instead, we should write object. And then we can give in the parameters of our multi-scale. So by default, we can put it as 1.1 and 4. But if the user wants to change it, they should be able to. So we can write here scale factor is equals to 1.1. And then we can write minimum neighbors is equals to 4. So these are the values by default. And we can replace this by scale factor and the 4 by minimum neighbor. So now this way it is generic, but one more thing, when we are using image here, that's not a very good idea. What we want to do, because this is a global, it's been declared here, so it will try to access that. What we can do is we can make a copy of it. So we can say that image object is equals to image dot copy. So it will make a copy of that, and then we can place it on the new image instead of the old image. And then what we can do is we can return some values. So you have to think about what exactly are you looking for from this function. So what we need is, one thing is that we want to draw the rectangles around the faces detected or the objects detected, but that's not it. We will be needing those values as well. When these values change, we want to know what kind of change, how much the change is. So we need to send in the output image, and then we also need to send in the actual values of our X, Y, W, and height, the width and height. So what we can do is we can return, and what we can return is the, first of all, image objects, and then we can return the objects themselves. So what are these objects? These are basically the ones that we found. So instead of faces, we are going to call them objects. Okay, so that seems good. Now, what else can we do? I think this seems fine. Let's save it and let's run it. So if we run main now, it should run this part. And here we need to give in our parameters. So we will say that we are sending in our image, and then we have our face cascade for our object detection. And then we are going to receive the image objects, and then we need the objects as well. We're not going to do anything with those values, but still we will unpack them, or we will get it from our function. Okay, so this is the idea, and hopefully this will work out well. So let's run it and see what happens. Okay, so we have face cascade is not defined. So in which line? Line number 8. So in line number 8, face cascade is not defined. So we have to copy this and we have to paste it here. We will save it and let's run it again. Okay, so image objects. So here there is a spelling mistake. Objects. Yeah, that should be fine. So hopefully third time's the charm. Nope, not even third time because we forgot here. Okay, let's try it again. Okay, fourth time's a charm. So yeah, there you go. So now we have it as a function, so as a separate function, and we can call this function from any other script, and we can use the functionality of this particular function. So this is great. And right now it's a very small code, so it might seem a little bit redundant, but when you start working in a modular fashion, it becomes very easy to migrate from one project to another. because you already have the basis. All you need to do is put it together as Legos. So now that we are done with the object detection module, one more thing that we want to do before we finish this is to write your docstrings. So we want to comment our code so that it is easier for us to know what we did later on, and it is easier to maintain as well. So what we will do is, for each function, we are going to define what are the input parameters and what kind of return are we getting. And then we will also define the main concept of the module as well. So here, to declare a docstring, you have to put 3 quotation marks and then another 3 to end it. So in between, we can write whatever we want. So in this case, we are going to write object detection module, detection module, and we can write that this is using Viola Jones method, and I think Jones. So that is the idea, and then you will write any detail of how it works. Now I'm not going to write too much here, but you feel free to write whatever you feel comfortable with. Now here in find objects, we are going to do the same thing. So we are going to write docstring, and we have to write, first of all, what does this function do? So we can say that finds objects using the har cascade file, and then we can write the parameters. So we can say here param, and then we will say that, so for each parameter we have to define what it does. So here we will write image, and then we have to write image, let's say, in which the object needs to be found. Then we have object cascade. We can write object, let's say cascade created with cascade classifier. What else can we write? We have the scale factor. So we will write here param, and then we will write scale f, basically how much the image size is reduced at each image scale. And then we have param, and we have the minimum neighbor. With the minimum neighbor, basically the idea is that how many neighbors each rectangle should have to accept as valid. So these are the parameters. So, and then the last thing we have to write, or we should write, is return without the space here. And in the return, we have to write whatever we are returning. So we can write here that we are returning the image with the rectangles drawn and the bounding box info. So these are the two things that we are returning. So that should be good enough. And of course, you can write your credentials here as well. So because I am the one writing this, so I will write my name. And if you want to give in your info, you can write here as well. So maybe I can write my website, www.murtazahassan.com, and the YouTube channel is Murtaza's Workshop robotics and AI. So yeah, that pretty much sums it up. So now that we have all of this, if somebody comes up and reads all of this, hopefully they will be able to understand this as well. And later on, in the long run, if you come back and read your own code, you should be able to understand this as well. If you like the video so far, give it a thumbs up and don't forget to subscribe. So we can change this value to find our optimum color. So here you can see, if I change it a little bit, you can see there's a change. I can reduce this until it just remains with the color that we want. There we go. And then we can go into the next part. Now it starts to get shape and it looks much better. Okay, we need to step back a little bit. Okay, and then in terms of value, there you go. It's getting sharper and neater. So you can play with these values all day long. So now it's drawing all the contours. So if we want all the contours, we will put 0. If we want a specific one, we will put that specific value in it. In this chapter, we are going to learn how to use our GPIO pins on the Jetson Nano. Now the thing is that they are very similar to the Raspberry Pi GPIO pins in terms of the numbers and the layout, but when it comes to functionality, they are quite different. Especially when you are trying to use it with different components such as LED or maybe a servo motor or maybe DC motor, so things get a little bit different. Now, Jetson Nano GPIO pins are not as powerful as the Raspberry Pi pins. They do not provide enough current for example, LED lights. So you do have to use a transistor to actually get the maximum current. And then if you want to use servos, you have to use an external servo driver. And then when you are using PWM pins, you have quite a lot of difficulty. You have to configure them. It's not as straightforward as a Raspberry Pi. And I also asked you guys which of the boards or which of the platforms do you prefer the most when you're using sensors or motors, and clearly the answer was Arduino. So we are going to do most of our sensors and motors in Arduino, but we are going to learn how to control the GPIO pins of Jetson Nano as well. So that if we want to do something simple, we should be able to do it without Arduino as well. Now, you can feel free to do all of the rest of the coding in simply Jetson Nano, but we will be using Arduino as it is simpler and it is more efficient in sensors and motors. So what we will do is we will start off with the basics of GPIO pins. So with the GPIO pins, the idea is that we are going to use the Raspberry Pi GPIO pin library, which is already installed on your Jetson Nano. So first we are going to connect our LED lights. So here I have connected it to pin number 17, 27 and 22. So these are the GPIO pin number, not the pin number in terms of the layout. So the layout is different on the board and the actual internal number for the GPIO is different. So we will be using the internal number of the board. So first of all, we are going to write here import RPI, and the R is capital, and then we are going to write GPIO, all of them are capital, as GPIO, and then we are going to write from time imports sleep. The idea here is that we are using an RGB LED light. Actually, it's not RGB, it's RBG. I don't know why, but they had to do it BG. Anyways, so we are using RBG LED light and we have one voltage pin, which means that will go to the 5 volts. And the rest of the 3 pins will go to your pin numbers 17, 27 and 22. If you look at the board number, it will be pin number 11, 12 and 13. So these are the pin numbers that we will be using. So here we are going to write, and by the way, if you put it as low, then it will turn on, and if you put it as high, it will turn off. So if you put all of them as high, it will turn off. If you put all of them as low, then it will be white because you have all the three colors. So let's start. We will write here a list and we will call it pins, and inside that we are going to write pin number 17, 27 and 22. And we are following the same configuration. So first we have R, then we have B, and then we have G. So once that is done, we are going to set our mode. So we are going to say GPIO dot set mode, and we are going to set it as GPIO dot BCM. So this will mean that we are not using the layout configuration, we are actually using the internal pin numbers. So it will be 17, 27 and 22 rather than 11, 12 and 13, something like that. So then we are going to set up our pins as outputs. So all of them are outputs. So we will write GPIO dot setup, and we are going to say that our pin number, is it pins? Yeah, it's pins at 0 is GPIO dot out. So this means it is an output. We are going to copy that and we will paste it a few more times, and we will change the pin numbers. Yeah, so far it looks good. And then what we will do is we will create a while loop. So we will write here while true. So first of all, we are going to turn on our LED light and we will put all of them as low. So that will give us a white color. So let's do that. So we will write here GPIO dot output, and then we will write here pins at 0, and then we will write GPIO dot low. So if you put all of them as low, you will get white color. If you put all of them as high, it will turn off the LED. So what we will do is we will try this. So let's run this and see what happens. And there you go. So now you can see that our LED light is completely white. So we can create the Arduino example. Here we can blink our LED light. So we can say sleep, and then we will write, let's say for 1 second, and then we will copy all of this and paste it down here. And then we will say high, high and high. So this will turn it off. So let's run this and see what happens. And there you go. So now we have the blinking example and it works fine. So next thing we will do, we will learn how to change the colors. So let's try out, let's say the first one, which is red. And then we will try out blue. And then we are going to try out green. So the idea here is that you have to keep all of them high except for the one that you want the color of. So all of them are high. Now for the first one, we need red color. So we will put this as low because our first pin is red. Then for the second one, we are going to put the second one low. And for the third one, we are going to put the third one low. So this way it will go red, blue and green. So let's run this and see what happens. And there you go. So red, blue, and green. And it will keep rotating and it will keep looping as long as we provide the power and we keep running the program. So as you can see, it is quite easy to run something like this with our GPIO library. And what we can do is we can create a module for this as well, so that it is easy for us. We don't have to set it up every time, and we don't have to write all these 3 or 4 lines of code to run our color or to send our color each time. So now we are going to create an LED module that will help us minimize our code when we are running it from different scripts. So we will create a new file and we will call it LED module.py. So in this LED module, we are going to copy the code of our GPIO Basics, which basically helps us run the LED. So here what we will do is we will make a few changes. So first of all, we can use functional programming to do this, but because we can have multiple LEDs, it's better to use classes. So we are going to create a class for our LED light, and then based on that class, we are going to create an LED object and we can change its color. So we are going to keep it simple like that. First of all, we have to make sure that we create our class. So here we are going to write class LED and we will write RBG. So this is the name of our class, and then we have to initialize. So we will write init, and then we have to write self, and then we need all the input arguments. So the input arguments will be the pin number of R, the pin number of B, and the pin number of G. So these are the 3 pin numbers that we need. And then we are going to get these values and we will assign them to this object. So we will write here self.r is equals to R. We will copy this, paste a couple of times, and then this will be B, this will be G, this will be B, and this will be G. So these are our values, and then we have to assign that all of these are outputs. So we will copy this part. In fact, we will cut it and we will paste it here. And instead of saying pins, we are going to say self.r and then self.b and then self.g. So these are the pin numbers that we will be using. So that is assigned. So we need to define our board. So here we have to write our mode here. So we can remove all of this. Now we need to create the method in our class so that we can change the color. So here we will define color and we will write self, and then after that we will write my color. So in my color, we are basically going to copy all of this and we will paste it here. So here we are going to say that if my color is equals to red, then we are going to run this code. And by this code, we have to make a little bit of changes to this code. We have to use self.r, self.b, and self.g instead of the pins. So we will write here paste, paste, and paste. And then here will be B and here will be G. So this is basically the idea, and we will remove all of this And here we will copy all of this and we will write else if. So we can bring this back and we will write here else if it is blue, then we are going to make the second one low and the first one high, and then we will copy this again, we will paste it, we will bring it back. Here we will write green, and then the last one will be basically your low value. So this is basically the idea, and if we want to turn it off we can do that too. Let's copy this, and if we want to turn it off we are going to write off, and this will be high. So same way we can put it as white as well. So HIGH. Okay, we can put it as white as well. So here we can write white, and we can put all of them as low. So based on what we are getting, we are setting our color. So that's how simple this is. Is there anything else? Okay, so now we can write our main loop. So we will write the main function, and inside that we are going to write our loop. And before we start with the loop, we have to define or we have to create our object. Let's call it my LED, and we will say that it is LED RBG, and the parameters are pin number 17, 27 and 22. So that's how simple it is. It will initialize it for us, and then we can assign it a color. So here we can say, for example, my LED dot color is, let's say, red. Then we have to call this. So right now it's just a function, we are not actually calling it. So we will write here if underscore underscore name is equals to main, then we are going to run our main function. So let's run this and see what happens. So there you go. So now our LED is red. Let's change it to green. Or let's write blue first. Blue. And we will kill the first one and then we will run it again. And there you go. Now it's blue. Then we can try green. And let's run it again. And there you go. So now it's green. So same thing you can do. Actually, we can try it out all together. So we can copy and paste it a couple of times. In fact, we need to put a sleep in between for 1 second. And then we can copy and paste. So what we will do is, we have how many different types? We have 1, 2, 3, 4, 5. So we are going to try all these 5 types here. 1, 2, 3, 4, and 5. So here we are going to start with red, then blue, then green, then off, and then white. So it will stay 1 second for each, and then it will move on. So let's run this and see what happens. There you go. So red, blue, green, off, and white. So that's how our program is working. So that is pretty much it. We have created our class for the LED RBG, and now all we have to do is we have to import this as our module, and then we can create an object, and then we can set its color. That's it. So we can add multiple LEDs as well. So this way we can use more than one, and it will be straightforward and easy even if you are using multiples. So I created a poll on my YouTube channel and asked you guys, which of the platforms do you prefer most when you want to use motors and sensors? And the clear answer was Arduino, not Raspberry Pi or Jetson Nano. So what we will do is we will connect all the sensors and motors to our Arduino, and we will communicate Arduino with the Jetson Nano using serial communication. So this is what it will look like. So we have our Jetson Nano, then we have our Arduino, and we are going to transmit the data between these two using serial communication using our USB connection. Now, the good thing about this is that you don't have to add anything extra except for the cable that comes with Arduino. So you will connect it to the Arduino, and then you will connect it to the Jetson Nano at any of the USB ports. And then to understand how all of this works, we are going to take an example of LEDs. So what we will do is we will look at how we can run these different LEDs, how we can send different brightness values to these LED lights. So this is basically our example. So the idea of Arduino is that if you want to send analog output, it will use 8 bits. So what is the meaning of 8 bits? 8 bits basically means 2 to the power of 8. That gives you a value of 256. Now this means that we have 256 values to play around with. So 256 will be the highest brightness, 0 will be the lowest, and in between, for example, 127 or 128 will be your middle value for the brightness. So if we include the value of 0 as well, then we have 0 to 255 as our range. So this is the data that we want to transmit. So the value will be from 0 to 255. So this means at any given point, the maximum digits that we can have are 3 digits. So we need to keep that in mind, that we want to use 3 digits at all times. So let's say that for the first value, we want to send the brightness of 50. So here is our value 50. And for the second LED, we want to send full brightness, which is 255. So if I want to send these two values from our Jetson Nano to Arduino and then to the LED lights, what I can do is I can simply send the value of 50 and 255. But the problem is that how will the Arduino know when does this 50 end and when does this 255 start? Because you can read it as 205 as well. You can read it as 5. You can read it as 5025. And you can read it completely 50255. So how does the Arduino know that where to cut it into half or where to divide it so that you have the first value of LED and the second value of the LED? Well, to do this, there is a very simple method. We will have always 3 digits for any LED. So what we can do is instead of sending 50, we will send 050. So this way it will have 3 digits, and then the next one will also have 3 digits. So whenever we are sending the value, we will make sure it has 3 digits for each value. So even if we have a third LED, let's say, we are going to send 3 digits only. And let's say if we were sending something that can go up to 1000, in that case, we will use 4 digits for each one of them. So this will become 0050, and then this will become 0255, and this will become 1000. So if we were sending something that can range from 0 to 1000. So this is the basic idea. So if we stick with 3 digits, we will send 050 and 255. But if we are sending 050 and 255, the problem is that if I'm sending it back and forth, then the values are transmitting like this. So this means the data keeps transmitting the same thing again and again. So how do we know where to start and where to end? So this will be a problem. So what we can do is, instead of doing all of this, we will add a dollar sign in the start. So our data will look like this. So we have a dollar at the first, and then we have 3 digits, and then we have 3 digits. So the dollar will represent the first value. So we will keep looking for the dollar sign. Whenever we get the dollar sign, we will extract the next 6 digits. And then we will split those 6 digits into half. That will give us 50 for this LED and 255 for this LED. So at the end of the day, our data will look like this. So we have each digit going to our Arduino board. So all of this will be sent from our Jetson Nano like this to our Arduino. In Arduino, we will have this data being transmitted here, and here we are going to split this data out. So here we will have this part as dollar. Okay, after that we will split it into this part, which will be sent to our first LED, and then this will be our second part, which will be sent to this LED. So this is how it will happen at the back end. To connect the Arduino to the Jetson Nano, we will simply plug in to one of our USB ports, the wire that comes with Arduino, and then we will connect the other side to the Arduino. And there you go. So that's how simply you can connect your Arduino board to your Jetson Nano. So first we are going to go to our store, and over here we are going to search for Arduino. And as you can see, I have already installed it. So it might take you a few tries to actually install. Sometimes it gives some random error, but if you keep trying, it will work out. And if it doesn't, you can always go to the Arduino website, download it from there, and install it from there as well. So once you install it, you can go back to your computer, and here you can search for Arduino. So once it opens up, you have to go to Tools, and you will check your Arduino board. Make sure it is the correct type, which we are using as Arduino Uno. And then you have to select your board. Here you can see we have the option of Arduino Uno. So we have the ACM0 as our Arduino port. So you do have to remember this. We will use this in our Python code. But for now, we will work in Arduino. We can maximize it. Now, the thing is, if this does not work for you, if you are unable to detect the Arduino board, try rebooting your system and then try again. So here, first of all, we are going to save our script. So we will click on Save. And in the desktop, we will go to our code. Here we are going to create a new folder. We'll call it Arduino, and inside that we are going to write our Arduino codes. And here we will say serial Arduino. Okay, now that this is done, we will start off by writing our initial code. So first of all, we are going to remove these comments, and in Arduino we have two main functions. One is the void setup and the other is the void loop. In the setup, basically you define which devices are inputs or outputs, and in the loop you write your actual code. And before the setup, if you want to declare something, you initialize the variables and constants above that. So first of all, we are going to define the number of values that we are receiving, and we are going to use define to actually write it down and not as an integer, because we want to use this value to declare the length of our array. So I will show you what that means. So here we will write number of values receiving. Let's keep this small, and we will write it as 2. So we are receiving two values. So for example, if we take the example of the LED, so we are receiving two values of two different LED lights. And then we have to define how many digits per value are we receiving. So here we will write define, and then we will write number or digits, let's say digits per val receive. Okay, so this will be 4, or no, it's 3. So we are receiving 3 digits for each value. So now what we will do is we will create an array in which we will store all the values that we receive. So for example, for LED1, if we are receiving the value of 50, and for LED2, we are receiving the value of 255, both of them we are going to store in a single array so that it is easy to access. So we can say that our integer vals receive is basically an array, and to define the length, we can use number of values received. So if we don't write define here and we write an integer, then we cannot use this value here. So that's why we are using define here. Okay, then we have the length of our string. So we can write here integer string length, length. So this is our string length. So we will have a $sign, and then afterwards we will have all these different digits. So what we want to do is we want to know how many digits are we expecting. So here we will write that it will be the number of values received multiplied by the digits per value received plus 1. So that plus 1 is for the $sign. So we will write that. And then we are going to declare a counter. We will put it as 0. And then we will write in the counter whether it started or not. So Boolean counter start. So this counter is basically, we will start counting whenever we receive the $sign. We will start this counter, and we will keep this value as true or false based on whether we have started or not. And then we are going to write here the string. This is basically the string that we receive. And then later on, we split it up into different parts and we store it in values received. So this is that string. Received vals, or let's say string. So this will be our received string. So these are the initial declarations that we have to do. And then in the setup, we are simply going to define our pin numbers. So for example, we can say pin mode. We can use the LED, internal LED for now, which is pin number 13. And we can say this is an output. So later on, right now we will just use one LED, but later on you can add more LEDs and try it out. But we will be receiving the values for two LEDs. Okay, then we will write here serial.begin 9600. So this is our baud rate. Now, if you don't know what baud rate is, you can think of it like speed, but you don't need to worry too much about it. So you have to make sure that what value you set here should be exactly the same that you set in your Python script. So they should match. So now we have to write a function to actually receive our data. So we will call this receive data. So it should be above the loop so that we can call it. So here we will write void receive data. So we are not expecting to send an output. So because we will be storing the value here directly, so we don't need to send anything out. So here what we will do is, first of all, we will write while serial dots available. So we will check for the data, and if the data is available, then we will do something. So what will be that something? Let's auto format. So what will be that something? So first of all, we will check the character. So our character, which is char c, let's say, is equals to serial dot read. So when you are reading serial data, it is character by character. So we are reading the character that we receive. And now we will check if this character is dollar or not, because that is our starting value. So we will say that if our character is equals to dollar, then we are going to say counter start is equals to true. So we want to start the counter if we have the dollar sign. So this is basically our idea. Then once it starts, then we will write here if counter start So then the counter will start and we will check that if the counter length is less than the total string length, then we will keep adding to our string. So what we are essentially doing is we are creating this string. So first our value will be, let's say 0. Then the next time it will be 5. Then the next time it will be 0. And then we will keep checking. Once the value reaches 6, so here we have reached 6, then we will say, okay, now it is done. So this is what we are checking here. So at the bottom here, we are going to say that if our counter value is less than the string length, then we are going to write that our received received string is equals to our received string, which was the previous one, plus C. And what we will do is we will make sure that it is an actual string. So we will write it like this. And once that is done, we will add to our counter. So every time this will happen, it will add to the counter and it will keep checking. So for 6 times this will run. And once those 6 times are done, then we will check that if counter is greater than, or let's say equal to as well, string length, then we are going to get our values. So once we have the complete string, so at this point, once this is done, so we will have it like this. We will have 050 and 255. So what we need to do is we need to extract this part and we need to extract this part. So how can we do that? For that, we have a function by the name substring. So this is a method that we can use. So we can write here received string dot substring, and we will write what is the starting value and what is the ending value. So here the starting value is 1 and the ending value is this. So 1, 2, 3, 4. So this ending value is 4. So this is how you can get your string broken down into pieces. And then we have to convert it into integer. So this is optional, because if you want to use it somewhere, maybe for a motor or for an LED, then you want to do this. So you will write here to int. So this is how you can get this. But the idea is that, and you can put it here. For example, you can write val vals receive, these are the values that we want to receive. We will write it as, let's say, number 0. And for the next one, we can write, this is 1. And then for this one, it will be 4 till 7. So this is how it will look like. But as you can see, this is basically a repetition. Right now, we only have 2 values that we are receiving, but let's say we were receiving 5 values. So we will have to copy and paste this 5 times. And this will be manual work that you will have to do every time. So what we want to do is we want to write a script, or we want to write this function so that it does it automatically. It checks how many values are we receiving, and based on that, how many times it has to split. So for that, we can create a for loop. So here we can write for integer I is equals to 0, and we will write I is less than the number of values received. So this is this value, which is 2. So it will loop 2 times. And then we are going to write I++. Okay, so now we need to automate this. So what we will do is we will first write an integer number, let's say num is equals to. So this is the number that will go over here and here. So what we can do is we can write I multiplied by digits per value, digits per val, or is it val received. Okay, so at the first point, this will be I will be 0 multiplied by digits per value. It will be, what is it, 3. So 0 multiplied by 3 will be 0, but we need 1. So we will do +1. So this will give us the value of 1 over here. So we can replace this over here by num. And then we need the value of 4. So we know that we have how many digits per value. We can simply say number, which is this number, plus the digits per value. So this will give us 1, and this will give us 4. And then after that, if you do the second one, I will be 1, and then digits per value will be 3. So this will become 3. And +1 will give you 4. So this means this will work fine. And then for number plus digits per value, this is 4, and this value is 3, so it will give us 7. So this means it works fine. So we can remove this line. And now if we have to receive more values, 3, 4, 5, it will work by default. And the only thing we have to change now is the value of I here. So whatever value we are receiving, we will send it to our array, and it will store accordingly. So this way we are receiving the values. And once we have set all the values, for the next round, we want to clear our string. So we will write here received string is equals to empty. And then we will say counter is equals to 0. And then we will say counter start is equals to false. So this way our counter will reset, our string will be removed, and we can receive the next values. So let's auto format this. And yeah, it seems fine. So let's compile and see if this will work. So let's compile here. Okay, there is an error. So probably because of the brackets. So let's try to find where is the issue with the brackets. So this is for the for loop. So we have 1, 2, 3. This one closes here. This one closes here. This one. Let's just remove one. Okay, so that seemed to be working. Now to test this, we can go to our void loop, and here we can, based on our received value, we can turn on and off our LED light. So what we can do is we can write here digital write, and we will give in our pin number 13 as high, HIGH, and we will copy this and we will paste it as low. So when do we put it high and when do we put it low? So we will say that if our is it values received? Yeah, vals received number, let's say the first value is equals to, let's give it a random value, let's say 27. If it is 27, then turn it on, else turn it off. So this way we will know if it is working, our script is working or not. So let's try it out. So we will first upload. Okay, so here now we are checking and we are getting this permission denied error. So this is common, this is not an issue. What we can do is we can copy this. We will copy this and we will go to our terminal and we will allow access for read and write. So we are going to say sudo change mode and we will give it 666. This means you can have read and write permission. And who do we want to give this to? We want to give it to our port, which is ACM0. So we will enter this and we will write our password and there you go. So we will close this and now we will upload. So there you go. Now the uploading is done. So that should be good. And now if we open the serial monitor, so if we type here $027 and 000, then this part here is the first LED light and this is the second one. So this should turn on our LED light because the first part is 27, as you can see, so it should turn on. So let's hit enter and it didn't work. Okay, why didn't it work? So we have the void loop if, oh, we didn't call the function. That is great. We have to call the function first so that we can receive the values. So there you go. Let's auto format. No, let's put a space. Okay, so let's run this now and hopefully this time we will turn on our LED light. So let's try it again. So again, we have to put $027,000 and there you go. So now you can see that we have our LED turned on. Now, if I send in any other value, let's say 000, it will turn off. Only with 27, it will turn on. Let me show you another digit. So let's say even if I write 26, it will not turn on because it is only programmed for 27. So this means we are receiving our data, we are splitting it up into separate parts and it is working fine. If you want to try out the second part, we can do that too. So here, let's say if we put this as the 1 and we want to check, let's say 255. So if the value is 255, then we will turn on, otherwise it will be off. So let's upload. Now we will open this up, and here we will write $000. So because this is the first one, and then the next one we will write 255. So as you can see, the light turned on, and if we write $0000000, it will turn off. We can also do the same thing. Now this code is basically kind of generic. So all you have to do is you have to define how many digits and how many numbers. So let's say we are receiving 3 numbers, but with only 1 digit. So then what we can do is, so each digit is representing 1 or 0, let's say. So we can write here, for example, we want the third value, and if the third value is 1, then turn it on. So let's try that. So let's open it up, and here we will write $001, and that should turn on our LED. If we write any other value, 000, it will turn off. 110, it will still turn off because it is looking for the last one. So that's how easy it is to actually write the data receiving part. Now this data receiving is a function that you can take in any script. You can write it down on any script and you can use its functionality. All you have to do is you have to write serial begin 9600, and you have to declare a few of these variables, and then you have to write receive data, and that should be good to go. So now that the Arduino part is done, we will go to our VS Code and we are going to create a new module for our serial communication. So we are going to go here and we are going to write serial module dot py. So this will allow us to write or send any commands or receive any commands. So for now, we will focus on the sending part, and later on, we will look at the receiving as well. For the serial communication in Python, we need a library called Python serial. So we are going to first install that. We will go to our terminal. You can use it here, or you can go to your main terminal here. And you can write here sudo, then apt get, then install python 3 -serial. So I will enter my password, and as you can see, it is already installed. You can see here it's already installed. So what we can do is, it will not be installed for you because I have already installed it earlier. So make sure that it is there. So to test it, you can write import serial, and then we can run this from the terminal, or you can right click and say open file in terminal, and there you go. So we didn't get any error. This means that we are good to go. So the first thing we will do is we will initialize it. So for that, we will create a function. We will call it initialize connection. So inside that, we will need two things. We will need the port number, and we will also need the baud rate. So these are the two parameters that we require from the user to define. And once we have that, we can try, because sometimes it will fail. So we have to use try and except. So we will write try, and we will say serial is equals to serial dot serial, and then we will write the port number, and we will write the baud rate. And if that works, we will write print device, let's put a space, connected. And if it doesn't work, also we will return this, return serial. And then if it doesn't work, except, we are going to print not connected. So this will tell us whether we connected or not. So here to check if it's working or not, we can write if underscore underscore name underscore underscore is equals to main. If we are running this file, then we are going to say create a serial, and we are going to initialize our connection, and we have to give in the name. So this name will be the one that is on Arduino. So if you go to tools, you will see here, this is the name. So you will write dev ttyacm0. So let's go back, and here we are going to write dev dash ttyacm0. So, and then you have to write the baud rate. This has to be the same that we used in Arduino. So if we go back to Arduino, this is the baud rate that we used, 9600. So we have to keep that the same. So here we will write 9600. So this will initialize. So if it works properly, it should say device connected. So if we run this, nothing happened because we didn't save it. Okay, let's run it again. Okay, so here you can see it says device connected. So that's a good sign. If I remove Arduino, let me remove that. I have removed it now. And if I run it again, it will say not connected. So let me put it back. And if I run it now, okay, let's give it some time. Still not connected. So here it's not connecting because we have to give access again. So if you remove it and plug it again, you have to give access. So you have to write sudo, and then you have to write change mode 666, and then you have to write dev ttyacm0. So that is 1, and there you go. So if I run it now, this says device connected. Okay, so that being done, we can move on. So now we need to create a function that will send our data. So we will write here send data. And to send the data, we need the serial. So let's call it SE. And then we need the data itself that you want to send. And then you also need to define how many digits do you need per value. So is it 3, is it 2, whatever it is, you have to define. So we can call it digits. And here we are going to, first of all, write my string. So this is the value of the string that we are going to send. So it should always start with the $sign. So we will write the $sign here. And then we are going to say that we are expecting this data to be an array, or in Python, you can say it's a list. So it will be, for example, if we are sending data, so we will write here send data. It will be ser here. And then let's say we want to send in 2 values. So we will write it like this. So we will write 255 and then 50. So these are the 2 values that we are sending. And for each value, we are sending, let's say, 3 digits. So let's go back to our Arduino. And here we will change it back to number of values as 2. And then the digits per value, we will say as 3. So here we will send 50 and 255. So we will check if the second value is 255. If that is 255, this will turn on. So this is our task. So let me upload that. Uploading is done. We can test it by writing here $. We can write here anything, and then we can write 255. And there you go. So the LED turns on. It means we are good to go. We can write 000 for now, and we can close this. So now we will go to our VS Code, and here, So we want to send in, let's say 50 for the first one and then 255 for the second one. So this will turn on our LED light. And what we can do is when we are sending it, so we first write the $sign, then we will unpack. So we will write here for D in data. We are going to loop through and we will keep adding to our string. So we will say that string plus the new string. The new string will be basically our value of D. So this is our value, the data. So for the first one, it will be 50. For the second one, it will be 255. So that is the idea. And then we have to make sure that if, let's say it is 50, it should be 3 digits. So if it's 50, it should be 050 and not just 50. So to do that, we have a function called zfill. This will fill in the zeros. So if we write, so here we have the digits to define how many digits we need per value. So if we need 3, then it will add 0 over here. So we can test this out by, we can print it later on. So we can remove that. We can print here the value, let's say my string, and we can see what happens. So we are calling this already. So we can run this and see, let's see what happens. So there you go. So here you can see device is connected, and then after that it will first use this string, and then when it loops again it will become 50 and then 255. So this is good. It means it is filling this. If we remove it, let's see, if we remove it and we save it, then you will see it will not add that 0. So that 0 is very important, otherwise our code will not work. So we can undo that and we can remove this. So we can add this print if it is sending properly. So again, we need to add try because it might fail because of some reason. So we can write se.write my string, and when you are sending it, you have to encode it. So that is the main idea. Now, if this works, we can basically print the string itself. If this doesn't work, then we can print, let's say data transmission failed. Okay. So this is what we can do. So yeah, okay, let's run it and see if this part works. So let's go back, and there you go. So device connected, and then it sent this. So it means it worked. Now, if we want to send it again and again, then we can simply write a while loop here. So we can write while true, then we will keep sending this. So here we can keep sending it, and as you can see, it just keeps sending this these values. So, and it keeps printing. So again, it is up to us. If we want to stop it to finish it, we can just put a single value. So to close it, we can simply hit this kill terminal. So now we can try it out with our LED light and see if it works. So let's run it again. Okay, no, this is not the command. Okay, we can right click here and run in terminal. And if we look at our Arduino now, you can see it turns on the LED light. Now let's close this, and what we can do is we can delay a little bit so that it blinks. So we can create that blinking example that comes with Arduino. So we can write here import time, and then we can write here time.sleep. and we will give it, let's say 1 second. And then we can copy all of this. We will paste it down here and we will send this value as 0. And then we can give a delay as well. So we can keep this 0 as well if we wanted. And we can remove this and put it as 0 as well. So first it will turn it on and then it will turn it off. And in between it will give 1 second delay. So let's run it. And there we go. So now our LED light is blinking. And the good thing is that the signal is being sent from Jetson Nano and it has been received by Arduino. So this is a great milestone that we have achieved. Now this opens up so much opportunity that we can use with Jetson Nano and Arduino together. Okay, so now it's working and you can see that if I change the value here, you can see the value changes. So it's flickering quite a bit. Okay, now it's fine because my hand was on the wire. So you can see here, if I rotate, you can see the value, it changes. So this is how you can get your data from Arduino and you can send in all these different kind of sensor values like ultrasonic or motion sensor or let's say potentiometer. So these devices, they can send inputs and based on that we can decide on some parameters and we can send back the values as well. So now we will discuss the process of eye tracking. So the idea here is that we have the camera inside our eye, which is represented by this, and then we have the person and this is the image that we get. So whenever the person actually moves, we will be able to track them. So we will have two types of movements, left and right, and then up and down. So we will talk about each one of them individually. So for the left and right, whenever the person moves towards the left, for example, we will try to move our image to the center as well. So we will always try to keep this line at the center of our object detected or the person detected in this case. So what will happen is that this camera will rotate and this image will come in the center. The same thing will happen if you go towards the other side. So it will rotate and now it will try to keep that in the center again. So this way we move left and right to keep the person always in the center. But the thing is that let's say the person moves towards the right and when you are rotating, you rotate too fast and then it might go outside or it might offset. So what you can do is you can rotate back and then it will bring it in the middle, but then again it will overshoot and it will go on the other side. So the problem here is that it will keep rotating back and forth and it will not settle anywhere. So let's say the speed is 50 at this point and whenever we reach the middle position, it should go to 0, right? So this is the basic concept. But what happens is that it doesn't stop at that exact point, it overshoots. So what you have to do is instead of saying keep 50 and then suddenly goes to 0, you can say go 50, then 40, then 30, then 20, then 10. So as you get closer to the actual object, the target object, you get slower and slower. This way, whenever you reach that exact point, you will stop at that exact point and you will not overshoot and keep oscillating. So this is the idea and this process is basically known as PID. So you have proportional, integral and derivative. So these terms, they check the error, and based on that error, we are going to multiply a proportional term, an integral term, and derivative term. So that's why this is called PID, which is proportional, integral, and derivative. So this will allow us to work both in the left and right and up and down. So for up and down, the process is pretty much the same. So here, if the person goes up, we need to move our frame up and the camera will go up as well. So the same thing will happen if you go down. If the person goes down, you will try to keep the person in the center and the camera will look down. So again, we will use PID to have a smooth control rather than jittery movement going up and down. We are going to use PID, and we will use proportional and derivative terms. We will not be using the integral term, and that should give us good results as it is. So we will not be needing the integral. So this is basically our idea. We will go up and we will go down based on the person's position, and we will try to keep it in the center. If you like the video so far, give it a thumbs up and don't forget to subscribe. So after the assembly and the wiring, the first thing we will do is to center our servos. So we want to find the middle of our servo range. Then we also want to find the maximum and the minimum. So we will go to our Arduino, we will go to examples, and then here we are going to look for the servo. So here we will click on the sweep. So this is the very basic example that comes with Arduino, and what we are going to do is we are going to change it a little bit. So this will be our template code that we will start off with. So we will copy all of this and we will paste it in a new file, and we are going to save it, and we are going to call it iCenter. So now you can see that we are including our library, then we are creating an object. In our case, we will need two objects because we have two servos. So we will copy this part and we will paste it down here. We can call this my servo left right and my servo up and down. So here again, we need to remove this. We don't need the position. So here we can write pin number 9, and then we have to write that we also have pin number 10. There should be a bracket. I think I removed it. Yeah. So now we will write here pin 9, and this will be pin number 10. So pin number 9 was left and right, and pin number 10 was up and down. So I think I wrote it wrong here as well. So up and down, and then what we will do is to send the command to our servo, all we have to do is we have to write myservo.write position. So whatever position we want it to move to, we have to write that. So we are going to remove all of this, and we will remove this. So here we can, for example, start with the left and right. In fact, we can do both at the same time. We can write up and down, And for both of them, we are going to give in our position as 90. So now we can run this. So in order to run it, we need to first check that we have our Arduino connected. And then we need to confirm that it is Uno. And based on this port number, we are going to write in our terminal to give it access. So we will write here sudo change mode 666 dev and tty acm 0. So there we go. So now it has access and we can upload this. So now we will put the positive connection back so that the servos move to the correct position, and then we are going to attach our servo tops back to the 90-degree position or the middle position. Now that both the servos are centered, we can remove this part and we can try out the range. So now we are going to try out the range. So for the range, we are going to do one by one. So we will do only the left and right, and then we will do only the up and down. So we will copy this part. And here we are going to add a delay in between. Let's say the delay is for 1 second. And then we are going to copy this as well. We can remove this one. We can add it later on. So now we need to check the range. So we will say that, for example, plus 20, and then we will say minus 20. So this way, it will go 20 plus and 20 minus. So if it's not enough, we can increase it later on. So let's try this out. So as you can see, it's not that much. So what we can do is we can increase it. Also, we want to bring it back to 90 as well. So after going left, right, we want to come to the middle as well. So we can actually, let's copy all of this. And then we want to write that go to 90 and then minus 20 and then go back to 90. So this way it's a bit more smoother. So let's try this. Yeah. So now what we can do is we can increase and decrease this. So let's say we can make this 35 and we can make this 35 as well. So now it's much better. Maybe we can go a little bit further, maybe 45 and 45. Yeah, so you can keep increasing based on how far you can go. So you should not go to the extreme limits. You should always leave some room between the extremes. So I think this value of 45 is good for now. Maybe we can change it later if we need to. So we can copy all of this and we can comment this by pressing Control and slash. and then we can paste it down, and instead of left and right we are going to say up and down. So I should actually turn it off first because it's very annoying. So we can always uncomment this and we can upload it, and it will go to the center and it will keep quiet. Okay, so let's run it again. So we were doing up and down, so we will paste all of that, and we will hope that up and down will have the same values. Let's see. Okay, I forgot to remove this. So this is not bad. We can increase it as well. So for now we are going to keep it like this. So our plus and minus is 45 for both of them. Later on, if we need, we can increase it more as well. So we can comment this, and of course we can write down here that this is for up and down range, and we can write it here as well that this is for left and right range, and this is for center. So let's uncomment the center and stop it at the center. So there you go. So now that we know the ranges and we have centered it, now we can move on to the next step. So now we will look at our main Arduino code that will run at the back end to receive the commands from our Python code, and it will send the commands to our servo motor. So here you can see that this is a file called iTracking. I have created this file and I have copied the code from receiving our serial communication data. So this is basically, we have our receive data function. So this will receive the data. All we have to do is define how many values are we receiving. So we are expecting 2 servo values, and each one of them can have a range from 0 to, let's say, 180. So we can have a maximum of 3 digits. So we are having 3 digits and 2 values. So this is what we will be receiving. So what we have to do now, we don't have anything in the void loop. So all we have to do is we have to copy this code and merge it with this one here, so that we can send the commands when we receive it. So here, first of all, we will go at the top and we will include our library. Then we are going to create our objects. Then in the setup, we are going to declare that both of them are outputs. Both of them are attached to pin number 9 and 10 respectively, and then we can send the command to go to 90 degrees, go to the middle at the very start. Then we are going to receive the data from our Python script or the serial communication. So in the void loop, we are going to receive the data. Once we receive the data, we are going to check the values inside them. So the values we are receiving, if you remember, are in values receive. So we will have 2 values, value receive 0 and value receive 1. So we can copy this. So this here is the value that we will be receiving for the first servo, and this here is the value for the second servo. So how can we send it to our servos now? Here we have my servo left and right. So we can copy that. We'll paste it here. We will remove this and we will put it here. So this is our values receive at 0. So this will be for left and right. And then we have the same thing for our up and down. So for up and down, we will have the value of 1. So from our array. So this is how simple it is to receive the values and send it to our servo motors. So to test this, what we can do is we can upload this code, and in the serial monitor we are going to write a sample data. So here we are going to open up our serial monitor. We know that we have to write $1 first, and then we have 3 values for the first servo and 3 for the second. So first of all, let's put them to 90 degrees. So we'll write 0, 90 and 0, 90. So there you go. Both of them are now 90, 90. Now we can move one of them. So we can say $0, and then we can say 90, let's say minus 20, we have 70. And for the other one, we will keep it at 90. So you can see now it moves towards the left. And if we want to move towards the right, then we can say, for example, 110 and then 0, 90. So it will move towards the right. And then we can test the up and down. So here we will say 90 degrees. We want it to go back. And then we want our up and down servo to go to 70. So here it's going up. And then we can say $90, and then we can say, for example, 120. So it goes down. So this way we can see that our code is working. Whatever values we will receive from our Jetson Nano after the image processing, we can send it through this string, and it will send the commands to the motor directly, and it will be able to communicate between the Arduino and the Jetson Nano. So now we have created an eye tracking project folder, and inside that folder we have put everything that is related to this project. So first of all, we have the HAR cascade file that will allow us to detect the faces. Then we have the object detection module that has the function that will detect the faces for us. And then we have the serial module that will send the commands to the motors whenever we decide to move the motors. And then we have the test.png file in case we want to test the object detection module. So all of this is taken from our previous chapters, and all we have done is we have created a new folder and we are adding all the files from our previous chapters. So the first thing we will do is we will make some changes to our object detection module. Now, there is not a lot we need to change here. We only need to write 2 extra lines of code. And the reason we want to do this is because we want to sort out the biggest object detected. So we want to find the biggest one. So we can add this functionality to our module, and it's not that we are doing this for this project. It will stay there and we can use it in different projects as well. So instead of writing it different for each code or each project, we are enhancing or updating our code. So it is, you can say, version 1.2. So the idea here is that whenever we get the objects, what we will do is we will put it in a list called objects out. And this is basically an empty list at first. And then what we will do is we will append our objects out with the X, Y, width and height. So this is the basic information that we need. And then we will multiply the width with height as our second parameter. So this will give us the area. So what we can do in the next line, all we need to do is we need to sort out our objects out based on a key. This key has to be a function. So we are using lambda, which is a 1-line function based on the second parameter. So x1 means this area parameter. x0 will mean this. So we are using the x1, which is the area, as our parameter, and we are saying that reverse is equals to true. This means that we want it in descending order. So the biggest one will come at first, and then the second biggest, then the third biggest, and so on. So this way, we do not have to worry about the detection part, because we will take the biggest one and we will use that as our face. So even if there is another face in the image, then it will not try to track that. It will try to track the closest one or the biggest one. So this will help us in that. The rest of the code is pretty much the same, only we added this first line, which is the empty list, and then we append the data, and then we sort out this list based on our key, which is basically the area. So this is good, and to test it, we can right click and run Python file in terminal. This gives us this output, which means that it is working fine, and now we can use it with our eye tracking project. So first of all, we are going to create a new file, and we will call this eye tracking.py. So here we will write import cv2, and then we are going to write import object detection module as ODM, object detection module, and then we are going to write, okay, entered that automatically, ODM, and then we are going to write import serial module as SM. And what else do we need? We also need imports numpy as np. So what else do we need? Maybe we will need time as well. We can check it out later if we need time. So the very first thing we will do, we will write down the parameters for the camera. So these parameters we will copy from our chapter number 1. So we will paste it here, and this is for the CSI camera, the Raspberry Pi camera, and we have the frame width and the frame height. So we can change this to 640 by 480. And we will keep the flip as 2, and then we will send in the cam set as our input argument. So then we can write down the serial communication. So we can initialize it. So we will write here serial is equals to sm dot initialize connection. And then we will write in the string. So we will write dev and tty acm0. So that should be good. And make sure that you have already enabled the permission. So if you haven't, you can copy this part here. You can go to the terminal and you can write here sudo change mode 666 and dev tty acm0, and that will give it the permission. I've already done that, but you can write it like this, 666, and then you can paste it and enter, and that should give it access. Okay, so once that is done, should we test it? Yeah, let's just test it if both of these things are working. So we will write here while true, and while this is true, so we can write success and image is equals to cap.read. So we are going to read our frame, and then we are just going to display it. So cv2.im show, and we will give in the name of the window as image, and then we will print out our image as well. And then we will write our if statement for the wait key, so that whenever we press the Q button, it will turn off. Otherwise, it will be hard to go to the terminal and kill it again and again. So this way it will be easier to do that. So we will accept the Q button, and if that happens, we are going to break. So we can save this, and now we can run it. Okay, we have an error. Okay, so we forgot to define the baud rate. So we have to give in 9600 as our baud rate, and we can run it again. And there you go. So right now you can see my webcam, and I have prepared this long stick with a face attached to it. So I will be moving this around instead of moving myself around, and hopefully this will work out good. So I think the power is on to the eye mechanism. So what we have to do is we have to remove the positive connection so that the motors, they don't move while we are coding. We just want to test it out. And one thing we can also do here is that we can write the command over here to send a 90-degree angle. So here we can write send data, and we are going to send to our serial, and then our values will be 90 and 90. And then here we can write 3 as our digits. So any given value can go up to 3 digits because the range is from 0 to 180. So that's why we are writing 3, and 90 degrees is the angle for both servos if we want to stop it. So now if we run this, you will see that it moves at first, and then if we quit, it comes back to 90 degrees. So that is a good place to start, and we can see that we are getting our image. Now next we are going to resize our image, and what we want to do is we want to resize it with the same aspect ratio. So we will use the scale function, and the reason we are doing this is to increase the speed of our detection. Now, object detection takes a little bit of computational power, so we are going to reduce that time by decreasing the size of our image. So we will write here image is equals to cv2 dot resize, and we are going to resize our image, and we will give in the value of 0 and 0 because we don't want to give any specific pixels, and we don't have any output. And then we will write 0.3 and 0.3. So we are using 30% of the image. So that will scale it down. And what we can do is to actually show it, we don't want to see it very small. So we are going to scale it up before we show it. So whatever image we get, we are going to scale it up. So we will write here 3 and 3, and that should scale it up back up. So if we run this, and there you go. So now you can see it's a little bit pixelated because we are scaling it down and scaling it back up, but it will definitely increase our speed. But if we don't scale it up back, you can see the size will be quite small. There you go. So you can see the size is really, really small. So that's why we are scaling it up to make it a little easier to work with. So now I have removed the cable of our positive connection so that we do not worry about the movement at this point. All we need to do first is to find out the center of our object detected. So the first thing we will do, we will go here, we will actually uncomment this. So now that we have our image, we need to find the objects in it, and then we need to find the biggest one with its center. So what we will do is we will call our modular function or our module, which is odm.findObjects. And inside that we have to give in our image. And then here you can see these are all the parameters. So this is kind of a standard. That's why it is showing up, because we have written all of this. And it tells you that you have to give in an image, and then you have to give in the object cascade. So in this case, we have the face cascade. So we will give in that, and we need to import our phase cascade, so we have to write it outside the loop. One common mistake is that a lot of people, they add it inside the loop. You don't want to import your cascade every iteration. That will slow down the process a lot. So you need to keep it outside. So phase cascade is equals to cv2 dot cascade classifier, and then we have to give in the name of our cascade. So we can just double click here, we can right click, and we can go to, okay, it's not available here. Then we can click here and press F2, and that should give us the option to rename. So we can copy the text and we can paste it here. And once that is done, we are good to go to import it. So we are sending in our phase cascade and we are finding the objects. So we need to get back the values. So there are two things that will be coming out of this, function. So you can see what exactly is returning. So in return, the image with rectangles drawn and the bounding box info. So we are getting two things out of this. So the first one will be the image objects, and the second one will be our objects themselves. So the information of the objects. So what we can do is we can replace our final image with the image objects so that we can see what exactly are we detecting. So we can save this and run the file in terminal. And this time around, I can bring in the face. And there you go. And you can see that the face is being detected. But you can see that there are some false positives as well. So what we can do is we can change our parameters over here. So let's say we will give in 1.1 for our scale factor, and let's say 5 for our minimum neighbors, and we can try that. There you go, a little bit better. So again, we can keep playing with these parameters until we are getting some good results. And you can see that in my background, there's a lot of objects as well. That is one of the reasons it is detecting more objects as well. If you have a cleaner background, it will detect less noise, and therefore the detection itself will be a bit better. So now that we have done the detection part, now we need to find the center of our object. So what we will do is we will create a new function. We will call it find center. And in that function, we are going to find the center of our object, and we are going to return the value of Cx and Cy, which is the center X and center Y. So we will need our image objects, and then we will need the objects themselves. So here we are going to first of all say that our Cx and Cy are -1, Cy are -1 and -1. And the reason for this is that if nothing is detected, then it will send -1 and -1 back. So in that case, we will know that if the center is -1, it means nothing is detected. So here we will check if the length of our objects is not equals to 0, then we are going to do something. So then we will update our Cx and Cy. So here we will say that our X, Y, width, and height are equals to the objects. First of all, if you remember, inside our objects we have Two things. The first one is the list of x, y, width and height, and the second one is basically the area. So we have to get the first one, which is 0. But here, this is a list of objects. The spellings here are wrong. Objects. So this is a list of objects. It's not just one object. So we need to get the first one because we have sorted it out and we know that the first one is the biggest one. And that is the one we need to track. So we will say that get the first one, and from that first one, get the first element, which is the x, y, width and height. So this is how we get our values. Then we can say that cx is equals to x plus width divided by 2, and then cy is equals to y plus height divided by 2. So this is basically our cx and cy. Next we can draw, because we have imported our objects. Okay, I've written the spelling wrongs for this as well. That is just great. A lot of spelling mistakes. So then we have to write down cv2 dot circle, and we can draw the circle. This will be our center point. So we will draw it on the image objects, and then we are going to say that we want to draw it on cx and cy points, and we will give it, let's say, the size of 2, and we will give it a color of green, 255 and 0, and then we will say that it is filled. So this will draw a dot in the center. And next, what can we do? We can draw arrows as well, the distance from the center, but let's just return this and print out. Let's see what happens. Return cx and cy and image objects. Okay, so then we can call this function. So we will call it by saying cx, cy and image objects is equals to find center, and we will write image objects and then objects. So now we should see a center drawn on our final image. Okay, so we have an error and it says objects is not defined. So this is where if length of objects. So I'm writing the spelling of objects wrong everywhere. That is just great. Okay, there you go. So if I bring in the face, there you go. So now you can see the center point is drawn. And if you see, when the wrong one is detected, it draws the center of only the biggest one, right? So this means our code is working properly. All we have to do is we have to make it a little bit harder for it to detect. So we can increase the minimum neighbors from here, for example. So let's put it as 7 and let's run it again. And there you go. So now it's detecting the face a little better, but still we have false detection, but it is lower than before. So what we can do is we can keep changing the parameters until we get that. So we can make this, let's say 10. Let's try it again. It is still there, a little bit less, but still there. So let's decrease this value. let's put it as 8. So hopefully it will be, yeah. So now it's not detecting. Okay, it's still detecting. So I think it might be because of my background as well. It's very noisy. So we can keep playing with the parameters. But for now we are going to move on, and later on we can come back to these, and I will try to change my background as well so that we can detect a little bit better. So now that we have our center point, what we can do next is we can visually show that how far away is it from the center. So how can we do that? We can do that by first of all getting the center position of our image, and then we will compute a line between the center and the given CX and CY. So how can we do that? We can write here image height, then image width, and then image channels is equals to image objects dot shape. So this will give us all the parameters that we require. So then we are going to write cv2 dot line. So this will draw a line, and we want to draw it on the image objects. And then where exactly do we want to draw it? We want to start at the width divided by 2 and then cy. And then we want CX and CY as the ending position. So CX and CY. So that is the starting point, and this is the ending point. So then we have our color. So let's put it green as well. 255 and 0. And then we can put the length or the thickness as 1. Then we can copy this and we can paste it down here. And instead of the width, now we will change the height. So this one was for the height, and now this one is for the width. So for the width, we are going to write here CX, and we will use I height divided by 2. So that is the idea, and let's try it out. So if I bring that in, and there you go. So now I can see the line from my center, how far away it is from my center point. So you can see in the horizontal direction and then in the vertical direction as well, you can see how far it is. So that is the idea. Now it looks a little bit weird because we are starting from the middle and there's no representation of the middle points or the middle lines. So what we can do is we can draw the middle lines as well. So here we can say that our height, width, and channel is equals to image objects dot shape. And then we can do the same thing that we did earlier. We will draw 2 lines. So let's copy them and we will paste it here. But this time around, these lines will be fixed. So we are basically drawing something known as a crosshair, which is a reference point. So over here, we are going to say that our width is divided by 2, but our height will be 0. And then our width divided by 2 again. But the height will be the final height, which is h. So this will give us a vertical line. And then we have to draw the horizontal line. So first we will say that start from 0. And the height will be height divided by 2. And then we are going to say that we have the full width and the height divided by 2 again. So this should give us our lines. Now we can change the color for this so that we know that this is for reference. And this is not live data, it is static. So here we will write 255. So this will make it purple. And let's run it now and see what happens. There you go. So now you can see nice lines right in the middle. And if I bring the object in between, now you can see the reference points are fairly clear and it is easy to see what exactly is happening. So when we go left and right and forwards and backwards, we will be able to, up and down, we will be able to see how far we are moving. So the next step is to actually track our objects. So now we know the center position. Now we are able to display it very nicely. It looks all good and nice. Now we need to track the objects and we need to update our servo values. So to do that, we are going to create an track function. So we will call it track object. So we will write here track object, and what we need the CX, we need the CY, and we also need the width and the height of our image. So because we are not sending in any image, rather we are sending just the width and height. Then we are going to define, first of all, we are going to check if our CX is not equals to -1. So if it was -1, this means that this length of objects was equals to 0 and there are no objects to be found. So then we are not going to do anything. So if it is not equals to -1, then we are going to do the left and right movement. So here we will write it down. So let's write it up here. Left and right. So here, first of all, we need to find the error. So our error is for left and right. So the left and right error will be our width divided by 2 minus CX. So CX is the current center of our object, and width divided by 2 is the middle of our image. So we will know how far is it in the horizontal direction. So that is our error. Then we need to find out the position of our servo. So we are using the PID control that we discussed earlier. So what we are trying to do is we are trying to relate the position of our image to the position of a servo motor. So normally you create a controller when two things are not relatable. So what we are trying to do is we are trying to relate them together using this PID controller. So what we will say is that our position for our servo is equals to, so here we will have the proportional term multiplied by our error left and right, and then we will add our derivative term, which will be d multiplied by error of LR minus previous error of LR. So we will have the previous error, so we can copy this and we can declare this as global, so it is easy to find. And we will also need the error for up and down, so we can just declare it now. So both of them will be 0 and 0 initially, and then as it moves along, it will keep updating. So here, when we write it down, we can write that our we are using the global values of p error LR and p error UD. So these are our global variables, and then we are going to create a list of our parameters, right? Rather than writing P and D. So we will write here that our parameters, so this is K, of our LR is equals to So we are going to create a list, and we can write here 0.5 and 0.5 as our initial parameters. And then we can do the same for our up and down, and we will write here 0.5 and 0.5 as our parameters. So we are not using the parameter I in this, we are only using P and D. So instead of writing P and D, we are going to replace it over here. So we will write the first element over here and the second element instead of D. So now this is our PID controller, and more technical term, it is PD controller. So then we are going to map our value that we are getting from this position X so that it ranges from the minimum servo position to the maximum servo position. So we tried out the values. So we tried out 90 plus 45, and then we got 90 minus 45. So we can give that range over here, and we can also try different values. And the maximum and minimum basically will be in negative and positive. So for example, we are getting the error of, or we are getting the position, the PID value or the answer we are getting is, let's say, minus 50. So we cannot send minus 50 to the servo motor because it does not understand that. We need to map that minus to maximum position from our 90 minus 45 to 90 plus 45. So that is basically the idea. So we will write here position X is equals to, so we are going to use the numpy functionality here. So we are going to write inter p, and then we are going to write that we want to map the position X, and our range is basically from minus width divided by 2, that is the maximum error we can get, and then width divided by 2. So sorry, the first one will be the minimum error we can get, and the second one will be the maximum we can get. Then we will write here the range. So we had 90 minus 45, and then we had 90 plus 45. So this is basically our range. So what we can do is we can play around with this. So I have tried out a few values, and I found that 20 to 160 works at the very max. So we are going to use that instead. So then we are going to update our error. So we will write here that our P error of left and right is equals to our current error of left and right. Error double R. Now, one thing to note here is that this value is not an integer, so we need to convert it into integer. Otherwise, it will not work properly. So that should be it. Now you can play around with these values, and you can play around with these values to get better results. So for now, let's just try it out and see what happens. So I will plug in the positive wire, and then we can try it out. But right now we are not sending it. So what we will do is we will write here simply sm.send_data, and we will give in that we are using the servo object, the serial object, and then we are sending in the position X. And for now we can just send 90 for the Y because we want it to be stationary, and then we have 3 digits. So that should be good enough. So you can see how simple it is once we have a module ready. So let's try it out and see what happens. So it doesn't seem to move. And why is that? Because we didn't call the function. So we need to call this track function. So let's copy that and we will paste it here. And we don't need to write anything else, do we? Yeah, it should be fine. Let's try it. Okay, so position X referenced before assignment. Okay, in case it doesn't, so we should not send. So if it's no object is rejected, we should not send. So it should be inside the if statement. Okay, so let's try it out. And there you go. So now you can see it's actually following, but it is flickering a lot. So we need to change the parameters so that it doesn't flicker that much. So let's go back here, and here let's put some other values. So let's say 0.4 and 0.1. Let's try it again. So now you can see that it is much better than before. But it is quite slow. It is not tracking that much. So we can increase this value, which is 0.4. Let's make it 0.6. So you can see it's a bit better than before, but still it's not perfect. So you can see that how you can change these parameters to actually get better results. So you can play around with these to get the optimum ones. So the same thing will happen with the second part, which is for the up and down. So here we do not need to check CY if it's -1 or not, because if one of them is, most probably the other one is as well. So this is left and right, and here we have up and down. So instead of LR, we are going to replace it with up and down for most parts, and we will write it here. Then this one will be P error up and down, and then we will replace this with P error up and down, and this one with up and down. And then we have position Y, then position Y, and then where is else? Here we have position Y. Yeah, that is pretty much it. And then we need to change this to KUT. So we will write here KUT. This will be 0, this will be 1. And what else? So the last thing will be the height. So here we will change it to height. Now you can change these parameters as well. You can make it smaller, the range to be smaller, and it will react more. So lastly, we are going to change this position 90 to position Y. And let's change the parameters for this as well. We'll keep it the same, at least for now, and later on you can play around with these values. So let's see, did we forget anything? Hopefully not. So we are getting an error because we made a mistake here. It should be KUT and not double K. Small mistakes everywhere. So there we have it. So if I bring in the image in front, you can see. Now the problem right now is that I am recording and it's lagging a lot. So what happens is that it tries to catch up, but it's very slow. So what I will do is I will stop the recording and I will record from my phone, and then I will display the result. And what I recommend you is to try out different parameters until you get the best results. And do upload them, do share them on the course page. What kind of parameters did work for you the best? So after the assembly and the wiring, the first thing you should do when you are building a robot is to test your motors. Now we need to write the code so that first of all, we know which direction we are moving in. So the very first thing I like to do is to run the motors forward. So what we will do is we will write some code so that the motor starts rotating forward, both of the motors moving in the forward direction. And that will be our initial testing code for the motors. And from there, we are going to create a function later on, and then we will implement it to our actual code so that we can communicate with our script. So here we have the robot motor test file. So this is just a new file that I've created. Now the very first thing you have to do is you have to open up your terminal and you have to write sudo change mode 666 and then dev tty acm0. Now this is basically the string that you will get. This is basically the port, so you can get it from here. There you go. So this is the one that we are allowing the permission for. So you need to grant it access, otherwise it will not run. It will not upload. So the first thing we will do is to declare our pins. So we have a lot of pins. So instead of creating variables, we are going to create an array. So we will write here, we have an array of integers and we will call it myPins. And we know that it will be of 6 elements. So we can write here 6, and then we can define each of these elements that are inside of our array. So here we will have 3, 4, 5. So these parameters or these pin numbers are for the first motor, and then we have 11, 10, and 9. The reason we are writing 9 at the end is because this is the same configuration that you have in your H bridge. So the H bridge enable pins are at the first and at the very end. So we are keeping up with the configuration that they have used. So as you know that our configuration is basically that we have one enable pin which basically controls the speed, and then we have 2 pins for direction. So if this is 0, this is 1, it will move in one direction. If this is 1, this is 0, it will move in the other direction. And the same thing goes here. 11 and 10 are direction pins, and pin number 9 is basically enable pin. So this will handle the speed. So the pin number 3 and pin number 9 will be analog because we need to give it a range. The range will be our speed, which will range from 0 to 255. And pin number 4, 5, 11, and 10 will be digital. So we will just send 0 and 1. So we will be simulating the analog by using the PWM. So PWM will be 3 and pin number 9. Now make sure you are using the same pin numbers. Pin number 5 and 6 are different frequencies, so make sure you don't use those for your enable pins. So in the void setup, we are going to declare that all of these pins, they are basically outputs. We are sending the commands to our motor. So what we can do is we can write here pin mode, and then we have to write the pin number, for example, pin number 3, and then we have to write output. So this is the normal way of doing this, and you can write it a little bit better by writing my pins at, let's say, 0, right? And then you have to write it again. So you will write it my pins at 1, my pins at 2, my pins at 3. So you can see it is repetitive. And whenever you have something like this, you can simply use a for loop. So that's what we will do. We will write here that for integer I is equals to 0, we are going to write I is less than 6, then I plus plus. So we know that we have 6 values. So that is what we will be using. So once you do that, you can put it in the brackets, and that should initialize all of these parameters. And then we can also initialize the serial dot begin in case we want to display something out. And then we have to write the code in our loop. Now what we will do is we will not write anything in the loop because we don't want it to keep running. We want to test it and we want it to stop. That way the battery will last much longer while you're testing. So what we will do is we will write here the code, whatever is required for our testing. So here I will write testing code so that there is no confusion. You could put it in the loop as well. Okay, so the first thing you will need is you need to define the digital pins. So here we will write digital writes, and we are going to say my pins at value number 1 is 0. So this means that our digital pin at this point is 0. So if this is 0, then the other one, pin number 2, should be 1. And the same thing will go for our second motor. So pin number 11 will be, here we will write 3 and 4. So one will be 0 and the other one will be 1. So this is for one motor, and then this is for the second motor. Now we can also write here the speed. So we will write here analog write, and in the analog write we will write my pins, and this time around we will write pin number 0, and we have to give in a value that will range from 0 to 255. In this case we are going to take a middle value, let's say 160, not exactly middle but a little more than that. And then we are going to copy this and we will paste it down here, and we are going to say that this is pin number 5. So pin number 5 is this, which is 9, and we will keep it 160. So after this we have to stop the motor because we don't want it to keep running. So what we will do is we will write a delay, and we are going to say that the delay is, let's say 1000. 1000 is actually low, let's put it 3000. So it will be 3 seconds, and then all we have to do is we have to put these analog pins to 0. So both of these pins we are going to put them to 0. So there you go. Now it should run once for 3 seconds and then it should stop. So I have put some standoffs at the back of the robot so that it doesn't move forward. While testing, this is a good idea because you will not have to chase it around, and especially when you are not using the modularity or the mobility of it, so that you don't have to keep worrying about the wires. So let's try it out. So we will upload it. So there you go. So now you saw that both of them were moving forward and then it stopped. Let's try it again one more time. There you go. So now if I wanted to change the direction of one of them, I can simply write 1 here, and then I can write 0 here. So one of them will move in the opposite direction. So let's see which one it is. So I think it is the left one. Let's try it out again. Yes. So the left one you can see is moving backwards. So this here is our left motor, and this here is our right motor. So this is our main idea, and what we will do is we will keep it at 0 and 1 so that it is always going forward. So this is our testing code. If any time during the testing or during implementation of new projects, new techniques, if anything goes wrong, this is the first thing you should come back to. So save this code separately. Whenever there's an issue, first of all check, maybe it is because of the motors, maybe the robot is tilting by itself, something is happening, and the first thing you should do is you should come back here and test this one out. So previously we saw that how we can test our code by writing a few lines of motor control so that the motors move forward. So in this testing code, we initialized our pins as outputs, all of them, and then we said that we want to move the right motor and the left motor forward at the speed of 160 out of 255. And that is pretty much simple. So now we are going to create a function out of this. So right now it looks a little bit messy. What we will do is we want to send one line of command, for example, move forward, move backwards with the speed of this, move left with the speed of that. So we want it very simple so that later on when we are implementing it with other strategies, we do not have to worry about all the tiny details or the lower level code of our program. So here we are going to start with creating a function. So we will copy all of the code that we wrote before and we are going to paste it here. We can close this and we can open this up. Here I have saved it as robot motor function. So we are going to create a function. So this function we are going to call it, so we will call it above the loop, or let's call it actually above the setup as well. so that we can use it inside the setup as well. So here we are going to write void. We do not want to return anything, so we are writing void. Then we will write move robot, and here we are going to take in two parameters. One is the speed, so I will call it my speed, and the second one will be our turn, so I will call it my turn. So these two parameters will basically tell you how much speed should I go forward or backwards, and then how much should I turn left or right. So as simple as that. Then we will have our max speed. So if in case we want to change it, we can write down here, we can send it as an input argument, but we will have a default value of 255, which is normally the case of Arduino. So here we are basically expecting the value of -100 to 100. And the same thing for my turn, we are expecting the values from -100 to 100. So the first thing we will do is we will map these values to our actual range, which is 0 to 255. So we need to do that. So actually it's not 0 to 255, it's -255 to 255. So we will map that values. So here we will write that my speed is equals to, we will use the map function, and we will say my speed, and the range is -100 to 100, and then minus max speed to max speed. So this is basically our my speed, and then we will write the same thing for my turn. So here we will write my turn, and we will copy that and paste it here. So again, you can change the values here, but we're going to keep it simple for now, and we will keep it like this. Then what we will do is we will write the individual speeds. So there should be a speed for left motor and there should be a speed of right motor. If both of them are same in the same direction, it will go forward. Both of them are same in the opposite direction, it will go backwards. If left one is more than the right one, then it will move towards the right. So we will write here that our left speed is basically my speed minus my turn. And then the right speed will be simply the opposite of that, which will be my speed plus my turn. So that's how simple this is. So one will be added and the other one will be subtracted. So this will give us the left and the right speeds. But now what we have to do is we have to make sure that the value does not go beyond our maximum or minimum range. So we need to constrain it. So we can use the constrain function. So we will say that left speed is equals to constrain left speed is minus max speed and max speed. So this will constrain it, and we can copy this part here, and the same thing we will do for the right speed like that. So that should work fine. Actually, we haven't tested if so far we have done any mistakes. Let's compile it to make sure there are no mistakes, and that is good. So no mistakes so far. Okay, so next we are going to check that our speed is in the positive direction or the negative direction. Then we will set out our pin configuration. So here we are going to write that if left speed is less than 0, then we are going to say that digital write, actually we can copy then. So if it's less than 0, or let's put it greater than 0. If it's greater than 0, then we should go forward, right? And this is the code for going forward. We already know that. So we will take for the left motor, we will copy this, and we are going to paste it here. So now we know that if it's greater than 0, then it will go forward. Else, we are going to say that we will move in the opposite direction, which is backwards. So here we will make it 1 and here we will make it 0. So let's just format our code, and then we are going to do the exact same thing for our right side. So we will write here right, and this time around, instead of 3 and 4, we are going to change it to 1 and 2. So here we will write 1 and 2, and then 1 and 2. Actually, we use the right values first, so let's just put it at the top. We can format it. There you go. So this is for the right speed and this is for the left speed. Okay, so now that is good. The last thing we have to do is we have to send out our speed. So here we will copy our speed and we will paste it here. Again, we will copy and we are going to paste it here. So these are the two speeds that we have to send. So we already know our pin numbers, but we do not know our speed. So 0 here is for the right speed and 5 here is for the left speed. So what we will do is we will write here right speed, and here we are going to write left speed. But the thing is that it does not understand minus values. So if you give in minus values, it will not work properly. So what you have to do is you have to write absolute, because we have already taken care of the direction over here. So we do not need to care about minus or plus. So here we can simply write absolute for the right speed and absolute for the left speed. So that is good, and we can remove all of this. So now you will see how easy this is. We will remove all of this, and here we are going to write move robot, and we will give in the value of, let's say, 30. So 30 will mean 30%, 30% of 255. And then we will say we don't want any turn, so we will keep it at 0. And we do not define the maximum speed because it is already defined. And we can copy all of this and we can paste it here, and we can change this back to 0. So now you can see that how easily we can write the commands to our motor. Instead of writing all these different parameters, we just have to write one line of code and it will do all the calculations and the processing for us. So hopefully this will work fine. So let's just upload it and see what happens. So as you can see, it worked exactly the same as before. So if I write minus over here, you will see that it will go backwards. And there you go. So now it's going backwards. Now we can introduce left and right, and we do not know at this point which way is left and which way is right. So we can figure it out here as well. So how you can do that is by writing 30 here, and then you can write, let's say, 30 over here. So one of the motors will stop and the other one will rotate. So this way we will know which turn it will take. So here you can see the right motor is rotating. This means that we are going to turn on the left side. So positive is left and negative is right. So if I write negative here, then it will go towards the right side. There you go. So again, this is an extreme example. Normally what will happen is that, let's say you have the value of 50 and you are giving a little bit of turn, so both the motors will move. So now you can see both the motors are moving. There you go. So it will curve a little bit. So again, if you want to increase the curve, you can add the value to here to this point. So this is basically your turn. So you can add positive or negative. So again, to make sure we remember this, we can write it down here, or we can write it in the function as well, so that it is easy to remember. So here we can write that turn value, or let's write first that my speed and my turn range from minus 100 to 100. Then we can write that positive value of my speed is forward, and negative is backwards. Then positive value of my turn is left, and negative value of my turn is, let's say, right. So we do not need to write it again. A negative value is right, so we can write it like that. So that will help us remember what we did later on, and of course we can auto format this so everything looks nice and good. So again, this is again for the testing code, so this should be in the void loop when we are actually running it. So there should be constant values going in. So whatever script we write in Python, it will send us the values of our motors. So we will directly input them over here using our serial communication. If you like the video so far, give it a thumbs up and don't forget to subscribe. So here we have the two files that we created earlier. One was for the robot motor function, which allows us to conveniently send commands to our motor, and the other one is for the serial receiving. So this code actually helps us receive the signal using serial communication. So we are getting the numbers from our Python script, and we are using it in our code in the void loop. So here we used an LED light. So we are going to use this ideology, but we are going to send the commands to our motors instead. So what we will do is we will copy all of this and we will create a new file, and we are going to call it robot underscore motor underscore serial. So this will be the serial control for our motor. So we are going to increase the size of this and we will paste it here. So now we will go back here and we need to copy all of the motor part from our motor function. So we'll copy the pin numbers. So let's just put it down here. So let's just put it down here. And then we need the function move robot. So we are going to copy all of this. Then we have our function receive data, which is fine. Now let's put the setup actually below that. And here in the setup, we are going to initialize all of our pin numbers. So we will write here that all of these are basically outputs. And then we have our testing code. So we are going to go here. We will remove all of this. Actually, let's keep this. So this is how we will use our values coming from the Python script. So what we will do is we will copy this part here, and all we have to do now is copy this, paste it here, and then paste it here, and that's it. So this should be value number 0, this should be value number 1, and that's how simple all of this is. So now we should be able to receive the values of our motors from our serial communication and send it to our motors. So one more thing that we have to make sure is that how many values we are receiving. We are receiving 2 values. One is for the speed and the other one is for the turn. And then how many digits are per value? There are 3 digits because our value can range from 0 to 255. Actually, that is wrong. In this case, we need 4 values because our value can range from minus 255 to 255, or you can say minus 100 to plus 100. So our values should be digits of 4. So we need to update that here. So we can have minus 100 to 100 for both my speed and my turn. So that is basically our idea. So let's upload this. Then we are going to open up our serial monitor, and here we are going to write the $sign, and the first value will be of our speed. So let's say we write here 0030 means go to 30%, and for the turn, for right now we can write 0. So we will write 4 zeros for the turn, and let's enter, and there you go. So now our wheels start moving forward. Now if we wanted to go backwards, we can press up and it will bring us our previous command. So if we want to go backwards, we can simply write here minus, and now you can see the motors are moving backwards. If we want to stop it, we can simply write here 0, and that should stop it. Now if we want it to turn, we can write the value here, for example 30. So now the motors are moving in the opposite directions. So this way you can see that how easily we are able to move our motors, and with just a single line of string we can both change our speed and our direction. So now we have created our robot car folder and we have placed it in the desktop. So here you can see that inside we have our 3 modules that we will be using in our project. So we have the serial module, the contour module, and the color module. So all I have done is I have created this folder and I have dragged it in to a new window of our Visual Studio. So here we are going to first create a new file, and we are going to call this keyboard control.py. So the thing is that there are a few methods that we can use to actually get the input from our keyboard. For example, we can use the Pygame, which is a library used for creating games with Python. But here we are going to take a very simple approach because our main goal is not to actually control it with keyboard rather than making it autonomous. So what we will do is we will use the CV2 library, which is the OpenCV library, to actually get the input from the keyboard and run our robot. So first we are going to import CV2, and then we are going to import time. So we might need it, we might not need it, so why not just import it? So then we are going to import our module. So we will write here import serial module as SM. Okay, it enters automatically, so we need to add a space and then enter. Okay, then we are going to write down our serial object. So here we can actually put it up here, and then we are going to write here that our serial object is basically sm.init, initialize the connection, and then as you can see we have already documented it. So here it tells us you have to write the baud rate, and you have to write the port number. So here we are going to write the port number basically as dev tty acm0, and the port number is 9600. So actually, before we go ahead, we do need to make sure that the permission is granted for this port. So we need to write here sudo change mode 666, and we will write dev tty acm0, and that should be good. So we can copy this. We can copy this and we can paste it here so that we remember to do this the next time around. Mission to the port. Okay, so that being done, next we are going to add in our camera. So we want to move our robot, but we want to display the image as well. So you can think of this as a spy robot that actually moves around and capture images for us. So we can write here frame. Actually, let's just copy it from chapter number 1, because for the CSI camera, the parameters are quite long. So we just want to copy paste. So here I have the document of chapter 1. So I can simply go down and we can copy all of this part, and we can simply paste it here. So the frame width and height is quite large, so we are going to reduce it down to, let's say, 640 by 480. We can reduce it further as well. We will keep the flip as 2. If it is required, we will change it, and that should be pretty much it. So next we are going to write our while statement. So we will write here while true, and we will write that our success and our image is equals to cap dot read, and then we are going to display our image, which is cv2.imshow, and then we are going to write results, let's say, and we are going to write image. So that should display our result, and all we have to do next is write cv2.wait key, and we are going to write 1 in the middle. So that should work fine. Let's test it out. So we will save this and we will right click and we will say run Python file in terminal. So let's see what happens. And there you go. So this is coming from my camera. Let me put something in front of it so that it is visible. So as you can see, the image is quite flipped. So what we need to do is we need to go back. Okay, we didn't define anything to stop, so we need to delete or kill the terminal from here. So here we are going to change the flip number. So let's put it as 0 and let's try it again. And there you go. So now it's in the correct orientation. So we can see that our camera is working fine. Okay, so next we have to write down that whenever we press a key, something should happen. So if you remember, we wrote earlier that whenever you press the Q button, it should break. So let's write that down first. So what we will do is we will call this as key, and then we are going to say that if the key is equals to ORD, and we are going to write Q, Then we are going to break. So this will break the loop. So let's run this and see if it works. There you go, it works. And then we can press Q and it shuts down. So that means it is working fine. So then we are going to continue with this concept and we will add more buttons. So here we are going to write that we will not break it for the other buttons. So we are going to write here that, let's say, if the key is equals to W, then we are going to print up. Print up. So we are going to use W, A, S, and D for up, left, down, and right. So that's why we are doing this. And then we can write here else if. Else if key is Q, then break. So let's save this and we can run this. So one thing that is very important to note here is that you should have clicked, or the main window that is active right now should be your OpenCV window. If it is clicked here, this will not work. So it has to be on the window and then you can press W. So you can see it says up. So now I can quit this. And the same thing we are going to do for the rest of the keys. So we will paste them, but we need to make it else if. So all of them are else if, and then W, A, or let's write W, S, A, and D. So this will be up, this will be, this will be down, this will be left, and this will be right. So that should work fine. So let's run it and see. So up, left, down, right. So I can try different patterns and all of them seem to work fine. So that's good. So now we are going to send our commands to the motor. So the good thing is that we have already set up the basis of it. So all we need to do is we need to send those two values of forward and turn. So we can send it from here by writing SM, which is our serial module, dot send data. And we are going to say that we want to send using this serial. And then we have to send the data. Our data will be, let's say 30. By the way, these motors will not run less than 30% of the speed. So if you're lucky, maybe it will run at 25 or maybe 20 at the least, but below that it will not work because these motors are not very high quality. They don't have a lot of torque. So therefore there is a minimum threshold, and that threshold can be 20%, 30%, or 25%, something like this. So we will be putting it on the safe side and we will write it as 30. So this is the minimum speed you can pretty much go at. And then we are going to write 0 for the turn. We don't want to turn when it is W. And then we are going to say that we have 4 digits per value. So that is the idea. So here, as you can see, whenever we move to that point, it will tell us what exactly does it mean. So it's basically bringing it up from here, down from here. So it's showing us here that this is the example. So all of this we did in our previous serial module chapter. So here, this will send the commands, and what we need to do is we need to copy all of this and we will paste it. But let's just test it first. So while we are running this, I can see that we are getting not connected. So we have already granted it access, but it still says it's not connected. So what is the issue? Okay, so this is wrong. This should be dev, and there should be a slash over here. So let's run this again and see what happens. So did it say not connected this time? Okay, it says device connected, so that means it's working. So all we need to do now is we need to turn on our motor, and we can press the W button and see if it moves forward or not. So when I pressed the W button, it moved forward, but you can see it kept trying to go forward, but because my cables are attached, it stopped. And let's see why that is. So the reason is that we are sending the data once it has been sent, and then there is no new data coming in, so it is keeping the speed of the previous round. So what we have to do is we have to write here else, and then we have to define that if that is not the case, then stop the motors. So if none of them, then you have to send in 0. Otherwise, it will keep trying to move forward. So let's try that again. So let's press W. Let me turn it on. So as you can see, now it is going a little bit to the left because, as I mentioned, my cables are attached at the back. But the good thing is that it is moving forward. We can see that when I press W, it goes forward. When I remove my finger, it stops. So that is a good sign. So what we can do next is we can set the back. So we will send here -30, and this should go back. So let's try that. There you go. So this is W going forward, and this is S going back. So then we can do the same thing with our left and right. So we will put this value as, should we put something? Yeah, let's put it as 40. And then for the left and right, we can give in some values. So for A, we are going to give 10, which is basically our left value. And then we are going to give -10 for our right. So -10. So let's see how that works. So if I move towards the right and to the left, to the right, you can see because my cables are holding it back, it's not moving that much, but it seems to work fine. So what I will do now is I will remove my cables, I will run it from the battery, and then I will make some videos so you can see how it works.